A very good afternoon to all of you. We are going to start our today's proceedings. Our today's topic is safety in offshore oil fields by Mr. Oshanendu Mondal, former Chief General Manager ONGC. And you see, Mr. Mondal is our contemporary, maybe 1 or 2 years senior to me. The thing is that he has taken up the brother of, as propounded by Sri Ramakrishna and Swami Vivekananda, that Yavat Bachi Tabat Sekhi. As long as we live, we should learn something. We should not forsake the teaching and learning throughout our life. And that's why, after getting retirement from the apex post of the great organization ONGC, he was a former chief. He was a chief general manager. So he has again thought that let him continue as a researcher, and he has registered for PhD in University of Calcutta, Department of Chemical Engineering. So that should be the spirit, I tell you. But because of his vast experience, Mr. Mondal is being invited to many areas by the many organizations. If you just go through his Facebook page, you will find that almost every week he is giving lecture to some very, top global platform. And we are very grateful that he has kindly accepted our invitation. So with this, I request Ashanendra to start his presentation. Already you are seeing the first page of the presentation. So we wish to, we request him to start his presentation. Ashanendra, please.
Thank you, Dr. Swamiji. Am I audible, sir? Am I audible?
Whether he is audible to all the participants?
Yes, sir. You are audible.
I am audible right now?
Yes, sir. You are audible.
Yeah, okay.
Yes, Ashanendra.
And I think my presentation slide also is visible, no?
Yes, sir.
Okay. Thank you, Swamiji, once again for giving me the opportunity to interact with the students. Although I am a student, as you have all mentioned, but my student's background is having a large industrial experience, which may not be with many of you. So I am delighted to say something from oil industry in this safety forum. So my topic name is safety in offshore oil fields. So how I am going to cover it, I'll give some introduction so that you will be knowing the idea about what I am talking about in offshore oil field about. And then what are the objectives, why safety is required there. Then I'll indicate some offshore accidents. And if we are to talk about the safety of offshore oil fields, then definitely we should know much more about the activities going on in offshore oil field. So I'll give a touch of that also. And finally, these things which are very important to take care of the property, to take care of the individuals working there, that is the safety aspects, safety measures, safety procedures. These three are very important. And finally, I'll give with a case study, which is talking about the accident in Mumbai High, or that time, or now also we can call it as Bombay High sometimes, of ONGC offshore oil field. So, see, what is oil and gas? It's basically a generic term is petroleum. It's a naturally occurring toxic and flammable liquid consisting of a complex mixture of hydrocarbons. So, all oil and gas will have hydrocarbons, means hydrogen and carbon. Oil usually contains four types of hydrocarbons. That is paraffins, means alkanes, olefins, means alkenes, naphthenes, means alicyclic alkanes, and aromatics, means cyclic compounds. So these four types of hydrocarbons, that is paraffinic, olefinic, naphthenic, and aromatics, will be present in all crude oil. Crude oil usually contains 85% carbon and 12% hydrogen by weight. And the balance, very small quantity also will be there, that is sulfur, nitrogen, oxygen, and metals. Now, depending on the percentage of sulfur, the crude oil is termed as sweet crude or sour crude. This is very important because in a particular refinery, whether that refinery can process sweet crude or sour crude, that has to be decided in the beginning of the designing itself. And so that's why if a particular refinery is designed for sweet crude, it cannot process sour crude. Similarly, if it is for sour crude, it can process sweet crude, but it will be costlier for designing point of view. So that's why the sulfur ppm is very important. If it is less than 0.5, we say it is sweet crude. If it is more than 1%, it is known as sour crude. And natural gas, this is also available along with the crude oil in any oil field. It contains 82 to 99% methane and varying amounts of higher alkanes such as ethane, propane, butane, and sometimes a small percentage of carbon dioxide, nitrogen, hydrogen sulfide, and helium. Means you can say up to C4, C1, C2, C3, and C4 are usually available in natural gas. And of course, the maximum percentage will be methane, which is 82 to 99%. Here also, with related to sulfur or H2S, we termed as sweet gas and sour gas. If it is less than 4 ppm, then it is sweet gas. If it is more than 6 ppm, then it is H2S. Then it is sour gas. Now, when actually crude oil or natural gas was found, it is found in geological formations beneath Earth's surface. It is derived from the transformation of the remains of plants, marine algae, and bacteria into hydrocarbons under the prevailing conditions of temperature and pressure, and are formed hundreds of millions of years ago. Under surface pressure and temperature, the lighter hydrocarbons, that is methane, ethane, propane, and butane, occur as gases, and the heavier hydrocarbons occur as liquids. However, in the underground oil reservoir, the proportion of gas or liquid varies depending on the subsurface conditions. The gas from the oil is known as associated gas, and the gas from the gas oil is known as free gas. What is this slide is talking about? That crude oil and natural gas have been formed under the earth many millions of years ago from the remains of plants, algae, and bacteria. Whenever any catastrophe or any calamity is happening, they are getting under the earth. In that way, when they are staying there for longer durations, like million of years, then they get converted into crude oil and natural gas. And natural gas, if it is available along with the crude oil, it is known as associated gas. And if the gas is available without crude oil, then it is known as free gas. Three conditions must be present for a crude oil field or crude oil reservoirs. That is a source of hydrocarbon buried deep enough under the earth, a porous and permeable reservoir rock for it to accumulate in, a cap rock or seal rock that prevents it from escaping to the surface. It is talking about that this hydrocarbon, when it is buried under the earth, it has to be covered in a cap rock. Means when you just see here the down picture, here it is trapped, means it cannot, this natural gas and oil cannot go out from this rock. So this rock is impermeable rock or seal rock or cap rock, and within this field the reservoir has to be sufficiently large enough in a condition that they have got the porosity and permeability. Porosity means the number of pores inside the rock, and permeability means how they are connected in between. If the porous rock is there but there is no connection, so the permeability is less, then that will not be known as oil reservoir, because those oil cannot be connected with each other and we cannot take it up. So that's why the reservoir has got three typical characteristics. One is it has to be have hydrocarbon. It is to be porous and permeable reservoir rock, and the cap rock also is required so that it gets trapped. It is not going dispersed anywhere else. Within these reservoirs, fluids will typically organize themselves like a three-layer cake with a layer of water below the oil layer of gas above it, although the different layers vary in size between the reservoirs. What it is talking about, that as they are remaining there for longer duration, so there will be gravity change, and in that gravity change, although they will be almost mixed all together, but still the percentage of gas will be at the top and the percentage of oil will be in between and water will be in the bottom side. And these are known as reservoirs. These rocks are known as reservoirs which contain oil and gas. Some rocks are permeable and allow oil and gas to freely pass through them. Other rocks are impermeable, which I have already explained. What is permeability? Whether oil and gas rises up into the dome, yes, if it is anticline, then it will be capped by impermeable rock and it cannot escape from there. So it is known as oil trap, and that oil trap is ultimately converted to oil reservoir. The permeable strata in oil trap is known as reservoir rock. Reservoir rocks have lots of pores. They have the sponge-like activity, means number of pores are there which absorb oil and gas, and the reservoir or oil trap usually found at a depth of not less than 500 meter or not more than 5000 meter. Okay, you must have heard that oil was floating in Assam, so the depth was very less, but that was not a huge quantity. But practically, if we are to get a big reservoir of oil and gas, it has to be a depth of around 500 meter and maximum 5000. Sometimes it can go up to 6000, but it's very rare. We produce it from 500 to 5000 meter. Locating oil fields. How we can locate a oil field? So it's not a very problematic aspect, although it is very precious and very technically sound impact. But still, we can say it is not that easy because it needs a lot of interpretation. But before that, what we have to do? Our geologists use seismic surveys because as it is traced through sound waves, so it is known as seismic surveys to search for geological structure that may form oil reservoirs. The classic method includes making an underground explosion and observing the seismic response that provides information about the geological structures under the ground. Seismic surveys are used to locate likely rock structures underground in which oil and gas might be found. So what it is happening basically, you see this is a sound creator. This hammering is there. Earlier days, we were doing the explosion under the earth or under the soil, but nowadays we are doing the hammering from the top. Very big weight is being pouring on the ground number of times, and that is creating the sound which transmits below the earth. And whenever rock is there, it gets reflects or echo is there, and that echoes are getting picked up or captured through these called geophones. If it's in water, it is called hydrophones. If it is on the soil, it is known as geophones. And these geophones will be taking the echo, and from the sound generation to the echo, the sound echoing timings will be there. That will help them to understand from where the rock is there. And that rock may or may not contain oil, but at least they will come to know which type of rock is available under the earth. So this is known as seismic survey. And earlier we were doing through this online only. It is known as 2D. But if you are going spread, means both horizontally this way and that way, then it will be known as 3D survey. Nowadays 3D survey is available so that we can estimate the quantum of the reservoir area. Now, when we come to know that rock is there and probability of oil or gas will be there, then what we do? We need to drill it. Means from the top, we'll have to go to that level. So how we can do? Once oil and gas prospect has been identified, a hole is to be drilled to assess the reservoir volume, and once the reserve volume is determined, number of wells to be drilled. Volume of reserve, distribution of reservoir, type of depletion mechanism, economic consideration are guiding factors. Three categories of reserves are there: proven, probable, and possible. What it is talking about means when we have found that through seismic survey certain rock is prospective rocks are there, we'll go for drilling, means we'll lower the piping or tubing from the top and go to that level. And when we go to that level, then the reservoir characteristics will be identified through certain experiments. We'll have to collect the rock, we'll have to collect the sample and all those things. In case we feel that that area has got very big prospect and right prospect, then we know we term that as proven reservoir. If it is a probability 50-50, then it is known as probable. And if it is 10-90, means chances are there, then it is known as possible. So these are the three characteristics. In case we do not find any source of hydrocarbon after drilling, then that is known as dry hole or dry oil. The oil well is created by drilling a long hole into the earth and through an oil rig. This is a typical equipment which is used for drilling. This is for land. That's why it is known as onshore. If it is in water, it is known as offshore rig. So this equipment or this setup is known as oil rig. And what they are doing, they are lowering the tubing after drilling or exploration, we say. And finally, a collection of valves. After everything is over, then this is known as Christmas tree. Means there are number of valves which are used to operate how the oil and gas will be controlled over the surface. And in the bottom, you see these many casings are there. First casing, second casing, third casing, and fourth casing, like that. And the first casing is known as outer casing. It is basically protecting the loose soil not to fall down. So it is up to a certain depth. Then further we go for intermediate depth, and finally we go for production casing. This is very important. We need not to know much about this right now, but this has got very important aspects while oil and gas production will be there. And after this annulus casing and then the production tubing, we go for perforation. Means we perforate in many places so that they are now getting interconnected with the formation or with the reservoir rock, so that this oil now or gas now can enter into this tubing. How much oil is there, that for that we need to test many things like porosity, because that will let you know how much volume of rock is there which can carry or which can keep the oil and gas. Permeability, are they connected sufficiently or not? Then the saturation, this is very important. At that remaining pressure and temperature conditions, what is the saturation, so that we can understand the oil and gas proportion. And salinity, this is also very important. The water is there, and in that water, what is the salinity? If the salinity content is more, then definitely the process expenditures will be more, and the material construction also will be different. So these characteristics will be known after the drilling. This is post drilling. Okay. And how much oil is to be produced from oil, this is also very important. We should design for optimal flow, because if we take the total production at single go or in the beginning, then the oil has to come to the perforation from the distant locations at a particular speed available in that particular rock. So if we are taking more than that speed, then definitely there will be a detachment and we will not be able to take all the oil and gas. So we will have to leave there itself. So we will have to have a very essential requirement of optimal flow or optimization of the flow, which is done through choke assembly, which is available on the surface. This is how the oil and gas is being separated. But before I talk, I just wanted to know, is it clear till now what I have told? Can anybody say it is clear? Can anyone say what I have told right now, it is clear? I didn't get any voice. Can anybody sounds? Can anybody talk?
Yes, sir. It's all clear, sir.
Is it clear?
Yeah. It's clear, sir. All.
Okay. Any question comes in anybody's mind regarding how the oil and gas field is located, how we can identify the location, or how we can produce the oil and gas from any field. Is it clear?
Yes, sir. This is my question. How can identify the particular place?
Yeah, this is undoubtedly a very nice question, because the earth is everywhere, the water is everywhere. Where to find out that oil and gas is there, right? So I have shown basically this particular survey how to locate an oil field. This is first, the geological map is there. The Geological Survey of India has got a map under the earth where the plates are there. Means what sort of rocks and plates are in general available under the earth. Now from that, our geologist will identify certain locations. That is from their experience only. It is not that time known that yes, oil and gas will be found. So they go for seismic survey. Means they will test through sound waves. They will create the sound and take the echo, and from that they will identify the rock. After it is known, then the drilling will be there, and from that drilling, if the oil and natural gas or hydrocarbon source is available, then other tests also will be there. But these two, that is the seismic survey and then the drilling. This drilling is known as exploration drilling. These two are very essential to know whether oil and gas is there anywhere or not. Is it clear?
Yeah, yeah, yeah. Clear, sir.
Okay. Now next I
Fine,
am
thank you.
moving to next part. This is I am giving quickly. Basically, I am not going in details because I will have to cover the safety also. So this is basically whatever we have produced, oil, gas, and water. This comes here, and normally three-stage separations is there. They are all gravity separation. Means the retention time is sufficient to separate them. But to increase the retention, we are to have the baffles inside the vessels. Okay, and this is the gas which is going out, and then we have to do the make it moisture free or water free. So we use the triethylene glycol for dehydration, and then it is going to the market. And this from everywhere, the first stage, when the liquid will be coming up, here the water is coming out, this water is coming out, and this liquid, this is the oil, and when it will be coming in the second stage, again the gas will be taken up, and the liquid or oil will come down. Like that, it normally goes up to three stages. And the top here, as this gas pressure is less, because these are the pressures are different in each separator. This is the highest pressure operating, this is the next, and this is the lowest pressure operating. So in that way, the flow is there, and in that way we capture the gas and we capture the oil. When oil goes into the refinery and gas going into the market for many purposes, like for generation, we can go for fertilizer plants, we can go for petrochemical plants, and many other purposes. Even we can go for cooking, like piped gas and all those things. And water is discarded. Here, one thing we should know, this is very useful for understanding the quality of oil. If it is light crude, then the API is 30 less than 31.1. If it is medium, 22.3 to 31.1. And if it is heavier or heavy, then it is less than 22.3. This is basically inverse of specific gravity or density. Light crude means the lowest density. Heaviest crude means highest density. So this is the formula. And after this oil extraction has started, we term it as the primary recovery, secondary recovery, and tertiary recovery. The primary recovery means whenever the perforation has happened in the tubing, we will have to take the oil and gas production from the reservoir, and that is because of the pressure difference it comes out. So we need not to do anything after perforation. Simply we have to allow that whatever is coming because of pressure difference to take it from the top or from the that Christmas tree. So this is known as natural flow. And in that natural flow, if it happens that the pressure has gone down into the reservoir with time, and this oil and gas or water cannot come up to the top, it comes in between the tubing somewhere in any depth, but it is not reaching up to the top because the pressure has gone down. That time we lift it. It is called artificial lift. and through that artificial lift, we can take it up. All these activities are known as primary recovery. In that way, we can go 25 to 30% of the total quantum. Now, as the pressure goes down with the time of production, then the best is that we can increase the pressure in the reservoir by injecting water or gas. If we are doing this activity or keeping the pressure support by this method, it is known as secondary recovery. In the secondary recovery, again we can increase the production from 20 to 25%. And finally, we can increase further recovery by enhanced oil recovery. What do we do? Here basically we are reducing the viscosity. Means the mobility is being increased, and if the viscosity is reduced, the mobility increases. So resistance also goes down during its flow. So by that way, again we can get more production, and that will give 15 to 20%. So the secondary recovery is basically targeting mobile oil. Hence viscosity is okay, but the pressure is low. But here, even if the pressure is low, high also, but as the viscosity is down, we are targeting the viscosity of the oil. So these three recovery methods can take up to 60 to 70%. Remaining production we cannot take from any reservoirs with the available technology so far. And the world recovery is 22%, US recovery is 39%, North Sea recovery is 46%, North Sea is UK, you can say UK, Netherlands, Norway, and all those, and India is 32%. So if we have to go up to 60% or so, we are now at 32%. So still production reservoirs are sufficient to supply oil and gas in future in India also. This is artificial lift. I am not going into the details. We can we can lift it basically through electrical pump, which is known as electrical submersible pump. We can go for a Sakarod pump also like this, which will be vertically going up and down, like tube well basically. It is taking something and we are removing it from the top. So it is called SRP. Or we can inject some gas, and that talking about that production casing is very important, because if we put the gas through that casing and take it into the tubing, then whatever is there in the tubing, that density will go down, and this additional pressure also will be used to lift it. So by that way also we can lift it. It is known as gas lift. Why the pressure falls? Because in any reservoir, as we said, it is inside a impermeable rock or capped rock. So definitely it's when the production goes on, then definitely some volume will go down. And if the volume goes down from any particular enclosure, then its pressure will go down. In that way, the pressure goes down. So if the pressure goes down, the driving force also goes down. So the production will be reduced or less. And otherwise also, when the pressure goes down, the viscosity increases and mobility reduces. So in that way, what happens, the gas mobility as it is faster, we can get more gas and crude oil will remain there. So it will give the gas cut. So we need to maintain the pressure from the beginning itself, so that we can continue with the production of oil and gas at a normal rate. This is for pressure support, as I said, the voidage replacement for water or gas injection, and this is for displacement and sweeping also. So how to achieve pressure maintenance? Pressure maintenance is possible by injecting water or gas, mostly these two. Somewhere we can put some diesel also if it is available, but as it is costlier also, as it is not abundantly available, so normally we target water, not even gas. These are all water injection characteristics. This is, you can typically say, this is a platform looks like this bottom picture. You see, this is the sea, offshore oil field, and in that offshore oil field is always beneath the sea. And these are structured. There are 8 legs. This is known as water injection platform. This is the oxygenation tower. Deoxygenation tower means oxygen from the water is removed. Water is taken from the sea itself by the lifting pump, and then it is treated. It is purified. I mean, you can say, filtered in 2 stages, and then oxygen is made free, and then it is injected. And this is called living water, where our people stay there during their 14 days working period. This is another platform basically. This is called wellhead platform. It is producing oil and gas also, and this oil and gas is used for the power generation purpose here. And this oil and gas is going to some other platform for further taking it to the shore. These are all characteristics, the quality of the water which is required to be injected, like total dissolved solid, then this suspended solids, turbidity, oxygen, sulfide, and all these things. UR, I am also not going to cover in details. The enhanced oil recovery we can do in many way. We can put oil, natural gas, steaming. This is very important because if we increase the reservoir temperature, then the viscosity goes down. This is the thermal expansion of the oil and gas there. And we can go for polymer, surfactant, and alkaline solution also, because this will create the surfactant like, means soapy like, so that the viscosity goes down. Or we can go for microorganism, means we can put certain bacteria which will react there to increase the production in long term. These are all classifications. I am not going into the details. If we are to talk about the cost analysis for these procedures, the surfactant is the most costliest, but at the same time, you see this is the total recovery. This x-axis is total recovery percentage, and the y-axis is cost, that is dollars per barrel. So you see, as surfactant has got more cost, but at the same time, it has got more production also. In the same way, water flooding, it will be less costlier, but the incremental production is less. So we can classify them from the expenditure point of view. Usually we go for CO2 and surfactant and thermal also. This is the most in between, that is the thermal, which has got both optimal production cost as well as optimal recovery. Now, as far as safety is concerned, okay, before I to go to safety, any clarification required for oil and gas field? Any more clarification is required for oil and gas field? No. Okay. Then I am going for clarifying the objectives. What are the objectives of safety in oil field? First of all, zero injuries and loss of life. There should not be any injury or any loss of life. No loss of property. No environmental damages. No damage to company's reputation. This is nowadays very important also. A company is recognized by its number of accidents happening, and that way also it can create the damage to the company's reputation. And finally, the safety standards like ISO, OSS, and MARPOL, that is for marine pollution. That is marine pollution means, because you are talking about offshore, so the seawater pollution may be there, and this is the occupational health and safety aspects basically. And this is ISO International Standard of Organizational Standards. Means you may be knowing ISO 14,000 is for environment, ISO 18,000 for the occupational health, and ISO 9,000 is for standardization, the quality aspects. So these are very important for safety, and this also gives the benefit like it minimize insurance premium. So whenever we have to go for insurance of our property, if these things are getting prioritized in that field, then definitely the insurance premium will go down. Productivity will increase because these happenings have been reduced, and loss of fears also will not be there. This is another important. The people will take up the job. Otherwise, if the fear is there, people may not take up that job and go to that field. So these three are very important advantages from these safety aspects. International petroleum industry functions according to tough HSE standards. There are very tough HSE standards which is required to be followed by any oil field. Yet accidents do occur. We are aware that even then accidents do occur. But definitely these HSE standards, if we are following, then the number of accidents can be reduced, or the quantum of the intensity of accidents also can be reduced. These are the examples of some safety aspects. And even then, what has happened? This is Alexander Lee Keeland semi-submersible. This is semi-submersible, means this is in deep water because this is not touching up to the soil. This structure has fallen down, has developed a crack after 5 years of its 6 years of its service in 1980, and it has killed 123 people on board. Then another is Piper Alpha platform. This is in North Sea. This has happened in 1988 and 167 died. This has happened basically operational failure, means mainly this is very important in any industry, that crew change will be there, means shift change will be there. When the shift change will be there, if the registers are not filled up properly what has happened by the earlier shift, then it will be very difficult to understand what is the field condition, because you cannot move the in the field all the time before your operation to start. So the register is very important, and if any communication gap is there in that register, then the operational failure happens. I am not going into the details, but this is one of the reasons which has created this total fire in that particular platforms. Then this is another semi-submersible. It is known as Petrobras 36. It is in Brazil. It has happened in 2001 and 11 people died. It is the technical failure. Means in the design, they had got an emergency drain tank, and that was not properly designed. So more that the volume of that has been tried to be drained out in that. And finally, the process controls could not be done smoothly, and this accident has happened. And last but not the least, that weather failure also is there. Sometimes before any platform is being designed, previous history of maybe 100 years data from weather is taken to design that. Even then, we may encounter certain bad weathers. With its intensity, it can happen. This has happened in 2002. Uh, that hurricane is known as Lily. It is in Gulf of Mexico, that is US Texas, and death report is not declared officially. About offshore oil fields. So offshore oil fields are filled bound beneath the sea. This is very important. Offshore oil fields means it has to be under the sea only. We can get some oil field on the land, under the land, or in the island also. But with the oil fields which are in the sea is known as offshore oil fields. The water depth can be less than 400 meter, which is known as shallow water. If it is 400 to 1000 meter, it is known as deep water. And if it is above 1000 meter, it will be known as ultra deep meter. Our Bombay High field is less than 80 meter, so it is also a shallow. And our KGD6, that east coast, is above 400 meter, so they are known as deep water. And some fields are also above 1000 meter, which we are trying to produce now with the newest technology, which is in ultra deep water. This is floating structures, this is semi-submersible structures, and this is steel structures. You see here the structures are shown, how they will look like. If the depth is less, it is a fixed platform, and then gradually it will go with the water depth. Offshore installations are run by platform manager, means there will be a single man, but under whom many people will be working for operations and maintenance, technicians, quality controls, drilling activities, well services, and workover. This is how to repair the wells if any cleaning job is required, or any reworking in the wells is required. That will be done through workover people, and support staffs like safety, medicos, caterers, cleaners, logistics. All these activities are happening in the platforms, and the platforms are connected with the shore by pipeline or even by dedicated tankers to take the oil and gas. The oil tankers are carrying the crude oil, and if we are to go for LNG sort of thing, which is not very common, we have to go for LNG tankers from the field itself. And the platforms varieties are process platform. This is the main platform where oil and gas separations will be there. The wellhead platform where oil and gas wells will be there. From there, oil and gas will be produced. The rig also will be there to drill as well as for workover job. The floating production unit also will be there in case the water depth is more and the platforms cannot be located easily. So we can go for floating system. We can go for multi-support vessels, the offshore supply vessels. These are for carrying the materials as well as for safety support. Oil tankers, Zodiac is just, I will show the pictures also, an helicopter. This is the process platform, as I said. This is the process platform. The living quarters also will be there, processing activities also will be there, and oil and gas production also will be there. And the compression facility will be there for gas to take it to the shore. Pump also will be there, oil to take it to the shore, and all those activities. And these are the facilities which are required to be created. That is power generation, potable water manufacturing, because drinking purpose we sometimes not in a position to carry water from the shore, so we can treat the seawater, desalination and reverse osmosis process to make it potable or drinkable. Utility and instrumentation here, which is very important for instrumentation purpose. Living quarters for staying. This is an example of how people remain there. This is called living quarter. And helicopter and boat operations will be there for transportations. This is wellhead platform. This is smaller than the process platform. Here you will find some wells. These are vertically, you can see. These are the lakes, but some more wells are also there. They are connected with the reservoir. And then separation is there for testing purposes to know how much oil and gas is there. And cold gas venting, there is no flare as such. And rig also can come and connected with this for the job. And what are the activities other than the main activity? There is the power generation and solar panel, utility or instrumentation here, pigging operation, that is for pipeline cleaning. There are many pipelines which can get accumulated inside through the debris, so that is required to be cleaned through pigging operations. Transit bunkhouse, we have a small bunkhouse also there in case emergency we have to stay there. And of course for logistic, helicopter and port operations. This is rig. This is used for workover and drilling purposes. This is the floating production and supply unit, basically you can say. This is a PSO. All these activities, more or less similar activities are there, but different in structure. This is multi-support supply vessels. So this has got a diver also. Those divers can go down and clean the pipe or connect the piping, welding and all those things, underwater welding and all those things. These activities are done through these vessels, and they have also got power generation, utility and instrumentation here, living quarters and helicopter and boat operations. This is offshore supply vessels. They are mainly used for materials to be shifted from one location to other location, and sometimes it carries the people also. After sunset specifically, if the helicopter service is not there, it can transport the people from one location to other location. And this is a typical oil tanker. In case the pipeline is not connected, then the crude oil can be filled into this tanker, and then this tanker can take it to the refinery. These are all helicopter services. You see how the people are getting moved from the shore like this. And this is called Zodiac. This is called Zodiac. Means the people are coming very close to the platforms by this means. The yardstick is in a platform is basically teamwork brings success, because as I have already clarified, so many activities, different of activities are there, many peoples are there. So teamwork brings success. Leadership ensures teamwork. Avoidance of accidents is the measure of success. Yet accidents happens, as I have said, but definitely it can be reduced through better teamwork and good leadership. And what are the safety aspects? Safety aspects basically, as you have already understood by this so far, that we are using hydrocarbon, and hydrocarbon is hazardous. Not only hydrocarbon is hazardous, the activities which are going on there means in the sea, for drilling, for workover job, for metal shifting, so many things are there. So they are all hazardous. Unsafe practices also may be there. People may not follow the safety rules. That also can create. For any hot job, means for any welding job, work permits is to be taken, because we will have to see that the area is hydrocarbon free or not. In case small accidents are there, that is to be noted down and to be rectified quickly. Failure of equipments also may happen. Vessels, pipelines, these failures can happen. Shutdown systems are there automatically. If they fail also, then accidents can happen. Communication gap also can happen. As I told one example of Viper Alpha also, the communication gap created the major accident there. Unskilled people, improper training, unfit workforce, they can also create the unsafe operations. Taking risk, This is also very important. Sometimes we take risk also. We, without following the proper safety rules, we proceed as if there won't be any problem. So that is also creating an aspect for safety. Not or no working safety detection system in case it is not being provided, safety measures if it is not being taken or working, and deployment of contractual labors. This is also very important because in our platforms or in many oil fields, all peoples are not a regular employee. We need to hire the contract laborers. They may not be fully aware of the total activities going on, and they may create certain problem, which is lead to the unsafe operations. So this is also very important. So hazardous, I have told also drilling activity, workover and oil repairing jobs. Process, I am not explaining because they are all understood. Still, I am just reading. Hydro testing means if you have to go for pipeline testing for pressure, commissioning in the beginning when everything has to be tested whether it is ready or not, high pressure of oil and gas handling, power generations. We have got both gas as well as diesel based power generation in the field, high temperature and noise area, electrical works, very high voltage electrical works and pumps are there. ATF, turbine fuel for running the helicopter, the diesels for running the generators as well as many other equipments, chemicals handling, helicopter and boat operations, train operations, working at heights, sea levels, gas flaring and cold vents, invading by outsiders, fishing boats and floating objects. These are also very important. In our area also in Bombay High, although it is around 170 kilometers away from shore, still we found a lot of fishing boats. They are not allowed to go inside. But as I have shown you, there are many oiled platforms which are not manned in the night. Sometimes they can come there and they can even go for pilferage of diesel also. So these things do happen and they can create the unsafe operations there. And what are the measures basically we should do for safety practices? We should go for training. This is very important. Every individual which is posted in offshore required to be trained. Then safety drills also are there because we need to ensure that yes, safety aspects are being followed. Installations of safety detectors, installation of firefighting devices, installation of life-saving systems. These three are very essential for safety measures. Then near miss reporting, installation of CCTV oblique radars, installation of smart cards, rescue oblique medical evacuation system, calibration of instrumentation because so many instruments are there. They need to be calibrated otherwise their failure can create havoc or hazardous situation. Tie up with Navy and Coast Guard. These are also very important. The Offshore Defense Advisory Group. There are many supporting requirements are there in any field to have rescue operations quickly, tie up with safety institutes and accident investigations. This is also very important. These are all safety measures to be taken. This is showing basically the CCTV and the safety shutdown systems. Then what are the safety practices? Display of safety needs, public procedures. This has to be displayed in many locations wherever people may do the mistake in maintaining the safety. Transparent interactions. The people should follow the languages very clearly. They should speak out clearly also, and registers also should be there to communicate in between. Monitoring of critical equipments, very essential. Smoking policy, this is another important aspect. In the living quarter only, we can allow the smoking, which is inside the pressurized chamber. Otherwise, outside, there is no smoking permissions available in any offshore oil fields. Gratings, railings, and riser guards will be there for easy movement so that people cannot slip. Corrosion monitoring so that pipeline does not create the rust and fail. Housekeeping and painting, this is another important area. We should keep everything in a proper place, not haphazardly here and there. Training, safety booklets and HSE manuals must be there. Hazard study has to be carried out, and ISO and OSS and audit observations have to be taken up time to time. The regional contingency plan or disaster management plan should be developed for any particular oil field. Fire and safety drills and safety competitions also will be there to encourage. Accident and near miss reporting also will be there, and checklist must be there. The awareness, these are all training aspects: awareness training, firefighting, safety of oil installations, survival at sea, H2S, how to work in H2S environment, how to operate the live boat, because live boat, you will not find any operator there to use the live boat. You yourself need to operate it in case of emergency. So you need to take the training of that also. You need to take the radio transmission also through the VHF, very high frequency and the radio equipments. And you should know that SOS language and all those things. First aid also you should know. Specialized skills for any particular field. And this is the new aspect basically, the helicopter underwater escape. This is available in Mumbai also. So in case helicopter crashes and people fall in the water, how that they can be escaped, that training also is going on. So these many trainings are required for every individual who will be posted in offshore. Then the fire drilling also will be there. They are all several sounds. I am not creating here, but they are captured here. So each sound will be familiar with you. What sort of accidents are there? These are all the pictures which are shown for drilling. This is the live boat. How people are to go along with their life jackets. All are to wear the life jackets, and these are all drills. Then near miss, I mean, there can be a small accidents like hit by objects, slip, leakage, electrical shocks, minor fire, lightning also. The lightning also can create havoc in the vents because a lot of hydrocarbons are getting released from that, and cold vending also are there in the field. So chemical burns and toxicity, poor illumination, which if the light is not sufficient, it can also create near miss, and the instrument actuations, ill health and violence to stop, and minor accidents. These are all near miss. These are not big accidents, but these are to be reported so that certain actions will be taken so that they will not get converted into the future and greater risk of accidents. These are all safety detection system like gas detectors also will be there, smoke, thermal, UV detector, H2, H2S, fusible plugs, and portable. Fusible plugs are basically that in case of high temperature, that plugs will get melt, and in that tubing, the pneumatic charge is there. The rail will be lost, and it will create the shutdown. And the portable meter also there to identify whether gas is there or not, smoke is there or not, like that. So all these detectors are placed, and these are all fire water safety systems. That is, fire pumps will be there, fire and foam water hoses, deluge system, sprinkler system, fire monitors, dry chemical powder system, CO2 snuffing system, nitrogen system, halon system, portable fire extinguisher, and external help like offshore supply vessel and multi-support vessels. We can go for external support also for any fire or any explosion is happening in the oil field. This is the personal basket, how the people are getting transferred from the platform to the sea. These are all various equipments. This is life saving equipments, means how finally you can save our life. This is life raft, life boat, life raft. This is life raft. This is life ring. This is scramble net. This is life belt. This is helicopter helideck net, because helicopter wheels also should not sleep. This is horns, fog horns. This is navigation lights, means in the night it will glow so that people will know that there is some obstruction or platforms. And breathing apparatus. This is the final safety kit. Then there are many safety procedures. Sometimes, okay, we have got various practices basically. They need to be followed, because what we have seen basically safety aspects, why safety is required, what are the measures there, and what like training and all those things. And then we should know that safety processes are to be carried out. Means they are not only for in the manuals, they are to be treated also. They are to be behaved and followed also, like work permits, hazard identification, maintenance of life-saving equipments. All these things are to be time to time maintained so that in case of real need, they will be available. Hot job and radiography, these are all work permit basically. Any jobs on routine job basically, non-routine jobs, which can create the accidents, they need to be permitted by work permits. So before taking up any job, they are to be created. I am not going into the details, but it is very essential for any oil field to follow for any job. This is assessment of hazardous activity. We need to create the level of hazards from their activities, and these are all the criteria and characteristics. Then how they will be maintained, basically, fortnightly, monthly, or quarterly, or yearly. So every equipment is not to be maintained daily. So there is a schedule. It is given by the manufacturer. We need to follow them judiciously and religiously, you can say, so that they are always available in time. This is again the maintenance. This is also the maintenance jobs. This is also the maintenance jobs. These are all maintenance jobs. So many, as I said, that from safety point of view, as well as from process control point of view, many things are there in the field to take care of safety. All these things are required to be maintained. This was given very emphasis time to time, because and the maintenance schedule also is to be followed, and it has to be audited also time to time. Now, even the health hazards, the people are okay from their health also or not, that is also to be tested. Up to 45 years, once in 5 years, 46 to 50 years of age, once in 3 years, 51 to 55 years age, once in 2 years, and above that every year. So these are all very important for health condition. This is for instrumentation checking. This is also for fire, and this is very important basically, because in case of real fire or man overboard, means man has fallen from the platform to the sea, in case of emergency evacuation or the vessel's collision or blackout, means no light is there. So what sort of precautions are to be taken in other than the safety aspects are carried out through this. And finally, okay, I'll go with a case study. This is called Bombay High North Fire, BHN. This is in our India itself, experienced by ONGC. This has happened in 2005. It has got major fire. You see, before fire, this was the structure. In the left hand side, you can see, and then these vessels came closer to this, and it has collided because of a very rough weather. In the Bombay also, it was very bad monsoon at that time, at 27 to 29 July. And when it hit, one or two risers got broken, and that created fire. So what happens? Collision of MSB. It is known as Samudra Suraksha. It is multi-support vessels. It was operating in Bombay field, and it came to the close to BHN platform for basically, you can see here, for transferring one person who has got finger cut actually during cooking. So that medical help was required at the time. For that, he was being transferred, and the fire has happened. That fire not only has happened to one platform, it has happened to all 4 platforms. So damaged adjacent BHF and MNW platforms. Fire gutted the platform within 2 hours. Within 2 hours, this has happened. 11 killed, 11 missing, and 361 rescued. This is, we can boast also as an ONGCN. Although it's a very huge fire, very bad weather, rough weather, it has happened in the evening time also. But just before evening, even then only 11 killed and 11 missing, 361 got rescued. So this is because all the safety drilling, safety training, safety aspects are followed meticulously. So that's why its impact has been very less. And the rescue has been carried out in bad weather through helicopter, vessels, coast guard, and navy. Many people floated in rough water for more than 5 hours. Many of them could be rescued as they were wearing life jackets, which is very essential for any offshore during work. Adjacent noble church, there is a rig also, which has also helped in rescuing some of the people. A cook aboard or Samudra Suraksha had cut his fingers. Samudra Suraksha came alongside, shifting the person, and it has DP, that is dynamic positioning. Still, it lost control because of bad weather, and the wells were closed from the remote system. So that's why the impact could be reduced. BHN was contributing almost 1,20,000 barrels of oil per day. This is huge quantity. Almost 40% of the total offshore productions are being produced from this location. 70% of the production recovered in 4 weeks' time. So this is another pride moment for ONGCN. that they could recover the production to be up to 70% revival within 4 weeks time, even without the help of this total activity in the field. Recovers received insurance from United India Insurance. So the insurance was covered, and that's why it helped a lot to get the money back. And finally, to conclude, safety is an investment. It is not an expenditure. This is very important. Sometimes we feel that safety is an expenditure. It's not correct. It is an investment because not only it reduces the manpower, life and property, but it also gives the premium to be less. So these are all factors. Time is up. Yes. Finally, one thing I must say, safety should ensure that everybody working at offshore can come back to their families safely and healthy at the end of their shifts. So this is our primary slogan, and this gives us the spirit basically to work in offshore. That's all. Thanks a lot.
Thank you, Shanmuga. Thank you for whenever I get your presentation, I see your presentation, I remember that several such, good presentations you had in the earlier cases. And whenever we go through your Facebook page, so it is totally loaded with just few days before you were in Calcutta Press Club. So I have seen that, anecdote. It's so nice. So I think that it is very much beneficial for the participants and also for the people like me. So thank you very much.
Thank you, sir. Thank you. I think there is no question, it seems, because this system also sometimes discourages the people to ask. Because if we are talking in face to face, then definitely many questions can be brought down from their mouth. But otherwise, in this system, I have seen people feel a little shy also to ask the question. So no doubt, I am available all the time.
Uh,
Even if any question come in your mind later on,
uh,
you can simply mail me.
just few months before, 2 3 months before,
Yeah,
the problem of ONGC at the Assam oil field. So I think you already
yeah,
you
yeah,
know this.
yeah, yeah,
So why such things happen? Can you
yeah, yeah, yeah.
say one or two words, one or
Yeah,
two
yeah.
sentences?
This is, first of all, this was not a ONGC field. It was a Oil India field.
Oh, I
Okay,
see. Yes.
Oil India Limited. But even then, we were, very close to that field. Our activities also are there, and we are operating in the same way, Oil India and ONGC. So, what has happened to Oil India? It's not that it is uncommon to ONGC. It is also very much common. But of course, the intensity of this Oil India was so high. It took almost 4 to 5 months time to get it controlled. What happened actually? The workover job for any field, whenever any oil is under production, we need to carry out certain jobs time to time so that the production rate can be improved or can be maintained. So that when that rig was doing that activity, we have got a foolproof blowout preventer also, so that suddenly such accidents should not happen. But even then, it can fail because the reservoir is having a lot of high pressure, and when it is exposed to surface, the pressure difference is high, and sometimes the gas pockets also may be there. So if you cannot control that properly, if the density of the tubing is not properly done, or if the blowout preventer did not be activated in time, there are many aspects. I will not go into details because there is a investigation report also. But this sort of activity can happen in any field. This is known as blowout, and that blowout cannot be. We also experienced in Ankleshwar also a few years before, but it could be controlled within 15 days or so. Here it took more time because the quantum of gas was very high under the reservoir. So that's why it took longer time. A lot of experts from Singapore and US came also, even from Canada, and finally they had capped it. They have, you can say, inverse bucket is placed over that Christmas tree and then sealed it. So that is the only possibility to do it because we do not have any other control. That gas which has started coming now we cannot control. because whatever safety system is there in the under the earth or in the tubing, that has also failed and blowout has occurred. So we are to cap only, and that activity was going on, and incidentally it took time, but now it has been made free. So the accidents happen because of blowout, and which is almost a common phenomenon. Although we all try to get it reduced as much as possible, but it can still happen. It is the sudden gas pocket which comes when operating in any particular well, or even in the drilling phase also it can happen also.
Okay. Okay, Akanandita.
Sir, I
So,
have a question.
Yeah, please.
anyone wants to have any question? No.
Sir, I have a question.
Yes. Yes,
Sir,
I can.
sir, are you audible?
Yeah.
Yes.
I'm here.
Sir, in case if there is an oil spill or accident underwater, then what actions are taken after that? Because the oil spill will cause harm to the aquatic animals, and
Exactly.
it is very dangerous for the maritime transactions.
Particular. Yeah. So
So,
I can just give you a small example, which is known as Mokondo. MOCANDO. If you just go through the internet also, you will find this has happened in Gulf of Mexico in 2010. Because of bad weather, that accident happened, a blowout happened, and all the oil spills were there in the sea, and it has almost ruined that company called British Petroleum in a very, very big way. So what they do, they are to basically put some chemical powder to get it. The dispersion has to be reduced first of all, because if the dispersion happens, because it is always will be as a interface floating over the water. So you cannot collect it easily. You will have to get it accumulated. So that dispersion, there is a chemical that they disperse from the surrounding and try to accumulate them, and then they pick up. But it is not a very easy job, and there is no other alternative basically. When the oil spill happens, you cannot get it diluted. You cannot put any bacteria to get it killed. Nothing will happen. Only you can try to collect it, to gather it basically, and to collect it. Otherwise, it will never be possible to spoil or to prevent from the deterioration. So you just go through that particular website. They have given full description of that, how it has happened, and it is a very huge job. It has taken more than 2-3 years, and lot of money expenditures have happened, and even there was no permission to carry out any job there also, but later on it has been neutralized. So this is the only possibility, because the impact what you have said, that is very correct. It cannot be avoided. There is no method basically uh, to avoid the oil spill if it happens, but it has to be collected by gathering through the chemical powder. Okay.
Thank you. Thank you, Asunandana. So
thank
our
you, sir.
next speaker, Professor Maikap, has already joined.
Yeah.
Asunandana, you can wrap up your
Yeah.
presentation.
Okay. I am stopping my sharing.
Yes. So Professor Maikap, Professor Bhimcharan Maikap, he is a full professor of Department of Chemical Engineering, IIT Kharagpur. Basically, he has 29 years experience for UG PG teaching, R&D, and he is also honorary professor of chemical engineering, UKZ in South Africa. Professor Maikap obtained his BTech in chemical engineering from Calcutta University and MTech and PhD from IIT Kharagpur. He is a fellow of Royal Society of Chemistry UK and Institution of Engineers India. His main area of expertise is industrial pollution control, fluidization, coal and mineral beneficiation. He has published more than 170 research papers in international journals, 4 books, book chapters, and 3 patents. Professor Makeup handled number of projects sponsored by Tata Steel, NTPC, State Pollution Control Board, Odisha, CSIR, DBT, Tata Chemicals, DST, Chhattisgarh Pollution Control Board, Messrs. Philips Carbon Black Limited, Kolakhat Thermal Power Plant, Hindalco, NRF of South Africa, etc. He has received many national and international awards. Excellence Award by NBC FDC, Ministry of Social Justice, Government of India, awarded to IIT Kharagpur for demonstrating successfully the CSR project 2019. Hetero Drugs, Professor G.S. Ladda, Kemcon Distinguished Speaker Award 2017 of Indian Institute of Chemical Engineers, ISHE, National Design Award in Environmental Engineering by Institution of Engineers, India, Hardelia Award 2015 for Excellence in Basic Research in Chemical Engineering by Indian Institute of Chemical Engineers, UKZN School Research Excellence Award 2011 of School of Engineering, University of KN Durban, South Africa 2011, National Research Foundation NRF established Rated Researcher D3 South Africa, GE John F. Welch Technology R&D Eco Imagination Award. He has guided 15 PhD and more than 57 MTech theses. Professor Maikap is a member of many professional societies like American Institute of Chemical Engineers, Institution of Chemical Engineers UK, Canadian Institute of Chemistry, International Water Association, South African Institute of Chemical Engineers, Indian Institute of Chemical Engineers. Professor Maikap is handling following journals as a capacity of editorial board member, Mineral Processing and Extractive Metallurgy Review, Taylor and Francis, and associate editor, South African Journal of Chemical Engineering, Elsevier. So Professor Maikap has got a very, very brilliant and emerging career, and above all, he is a great teacher. And in spite of his busy schedule, he has committed to us. Just I gave him a phone call and said he has accepted our request. We are very grateful from the part of our organizers that Professor Maikap has accepted our request. So I think the participants will be greatly benefited, and also we from his presentation. Sir, please start your deliberation.
Yeah. So, yeah.
Yes.
Thank you, sir. Thank you very much for introducing myself among the participants. It's my. Can you hear me all? Can you hear me, please?
Yes, surely.
Yeah. So it's my privilege to be here to share my thoughts and interact with you, although it is online mode. So let me go to my presentation. I will share the slides. Yeah, is the slide is visible? Is the slide is visible?
Yes, Professor Maikap.
Okay, good. So my topic of today's presentation is something related to industrial fugitive emissions, pollution prevention, and its control. As you know that when various type of air pollutants which are emitted from different industrial sources, they causes the main problem of the health hazards. So environment as well as associated health and safety is a big concern for many industrial situations. So in my presentation, I will try to give you some overview of following things: fugitive dust emission and its control. Mostly it is from industrial areas. Flue gas conditioning of the thermal power plant. So how to increase the efficiency of the electrostatic precipitator, how we can increase the performance by flue gas conditioning that we have developed. I will throw some light. Then wet scrubbing of the different type of air pollutants, and lastly pollution caused by our Indian thermal power plants and its prevention techniques. So first is the fugitive emissions. Now, what is fugitive emission? Fugitive emission is one of the major sources of particulate emissions from many material processing units like your coal, raw material, etc. where from the different source points as well as the transfer point, many many pollutants may be emitted, and it may cause the huge health problem to the workers or the people, those who are working in the plant. That means if a industry is operating, you will find, to find out the level of the pollution, practically we see on the stack or the chimney how dark or how or what type of the color of the gas is emitted. But if all the polluted gas is not properly collected through the different type of ducting layout, then what will happen? From the industry, that polluted gas will not be released through the chimney. You can't see them, but very close to the industrial premises, nearby the area, there will be a lot of huge pollutants will be emitted, and the peoples and the workers, those who are working in the plant, nearby community, that means villager, poor peoples, their house, you will find the rooftop in the millimeter level, dust particulate matters will be deposited, and that will cause a huge problem. When a vehicle will move, lot of emissions also will be there. So the existing pollution control devices are inadequate in many situations due to lack of proper maintenance and inadequate design features of the associated equipments. I will come with the example. So it has been observed that significant increase in concentration of the particulate matters emitted to the environment scatters the incoming sunlight and causes severe health problem of the workers associated with the plant, where this fugitive dust emissions is a very high concentration. As per the National Ambient Air Quality Standard, this limit is only 100 milligram per normal meter cube. But when you will go to the plant side, I will show you some of the pictures or some of the small video where you will find what is the level of the different type of pollutants which are emitted to the environment. So typical emissions, it may be in the gaseous type. That means gaseous means it is carbon monoxide, different type of hydrocarbons, right? Hydrocarbon vapor, sulfur dioxide, ammonia, H2S, nitrogen dioxide. Then particulate matters may fall into the following class: dust, smoke, fume, mist, fog, and other suspended particulate matters. So these are the typical industry or the processes. These are the source of the emissions, and these are the type of particulate matters and the control methodologies. I think some previous speaker already has discussed about the different type of control methods as well as the general air pollution control techniques. I am sure some of these things have been already discussed, but just to throw a light, so these are the typical name of the industry. These are the units from where the emissions are emitted, and different type of particulate matters may be iron oxide, dust, smoke, many things. It may come out from the plant. When any industry is emitting the particulate matters, there will be a lot of health issues as well as the diseases which are encountered due to the emissions of the different type of airborne particles. Particles are of two types. It is PM10 as well as the PM2.5. So if any type of PM10 or PM2.5 are emitted, then what will happen that through our upper respiratory tract, it will go to our lungs, and it may cause several problems to our entire health of the body. So we collected some of the data from the industrial hospitals in the Chhattisgarh. So this is one of the data of a hospital collected, that how these diseases, airborne diseases, that means asthma, bronchitis, cancer, respiratory infections, how these are, spread up across the different type of years. So sometimes it is always there is a chance that increase in nature of the different type of this airborne type of the diseases. So we collected many such hospital data, and we compared that what is the severity which is going on where there is large number of industries which are situated in an industrial cluster. Let me to take one example so that we will be able to understood that how this particulate matters are emitted from a, say suppose it is a from a from a typical it is a sponge iron plant. I have taken the example. So you see that these are the different operations one side, and this is the particularly one bag filter, right? This is the bag filter. So when the gas is cleaned, that clean gas is collected from here, and through the stack they are emitted to the environment. And our people are standing here. That means from IIT Kharagpur team, those who have visited the plant for investigating that what is the level of the different fugitive emissions and how it can be prevented. So if you see the simplified flow diagram, I think those who are the maybe chemical or metallurgical background, you can easily understood this. So this is the main kiln, rotary type of the kiln, where iron ore is being roasted, and two circuits are there. So this part is the coal circuit, where coal is grounded to fine powder form, and this iron ore circuit where iron ore is also grounded, and then it is being sent to this rotary kiln. So in the rotary kiln, at slow motion, rotary kiln will rotate. When you will feed the iron ore, which contains typically 56 to 58% of the iron oxide, then it will be reduced to give you the sponge iron in presence of this coal. So coal will be heated and it will give the calorific value, and it will be converted to carbon monoxide as well as the carbon that will act as a reducing agent. Then sometimes your limestone and other things is used to make it as a flux type of thing. So in the rotary kiln, this 56 to 58% iron content will be enhanced to nearly 90% iron content, 88 to 90%. So what is the scenario? That where the small iron ore mines are there, nearby that area, industrialists, they put up many such sponge iron plant, and from those sponge iron plant, from 58% of the iron content, they are getting almost 90% of the iron content material, which is the sponge iron. That means you can imagine that it will reduce significant cost of the transportation as well as processing. I mean, to make the iron bar or the different type of stainless steel product, it will be very easy if they are using that type of things. And then it will come to the gas cleaning tower, then the electrostatic precipitator, then it is going to the stack. Now, when the coal circuit or the iron ore circuit is used in the plant, then it consists of crushing, grinding, screening, or the separations. Those processes are very common. So during this process, there will be huge emission of the dust particulate matter. And if we are unable to capture those particulate matters through the ducting layout of the plant to the air pollution control equipment, maybe the bag filter, then what will happen? Such type of pollutions will completely make a health hazard issue to the worker or the people, right? So these are the different type of sources. These are the different type of the sources of the dust which are emitted. These are the proposed air pollution control equipment, and these are the Indian standards. So if you see, this is the flue gas from the kiln, point source, raw material handling area, coal circuit, iron ore circuit, all material transfer point, discharge point of the raw material storage bin, raw material feeding point into the kiln. So many things are there. Product separation, then your product storage, everything will come into the picture. So handling of fine dust particulate matter generally from these plants are very close to the room temperature. So bag filter is used in most of the cases if it is small to medium scale industries, and if it is large plant, then they try to use the electrostatic precipitator. And when the material is transported from one point to another point by means of belt conveyor. So belt will be moving like this manner. Yeah. So if the belt is inclined like this manner, and here the materials will be given like this, so belt will be moving upward. So this material will slowly go, and then it will fall down to the corresponding storage hopper or the storage bin. So when this material will fall a certain distance, maybe sometimes 10 feet, 15 feet, 20 feet, then immediately the solid materials will fall to the ground. There will be a lot of dust particulate matters which will be emitted, and those dust particulate matters, if it is not completely collected by using the appropriate suction, right, suction pressure, then it will create the huge problem, right? So in this picture, if you see, yeah, in this picture, if you see it, yes, if you see it, this is a plant, right, where molten iron ore slag is falling down, and from there, not only the it is just like the smoke, but it is not the smoke. In addition to the smoke, this type of at the bottom, how much the dust is lying, those type of dust is emitting, right? So this is one of the that ferroalloy plant from where such type of dust particulates are emitted. Next, you look for the diagram, right? So what is this? This pipe, it is nothing but the ducting pipe, which is connected to a particular hood, right, through which the particulate matter is supposed to be collected, and it will be sent to the bag filter. And those people, right, worker, they are now charging the limestone here into the furnace by using this so-called belcher, right? They are dumping it, and you see how much dust particulate matters are emitted, and hood should be very close to here. It should be covered here, but hood is 5 feet, 10 feet away. So why the dust particulate matter they should follow, and they should go inside this hood? There is no point, because that is far away from the that main furnace. So when the workers, they are dumping the limestone particles, limestone powders, lot of emissions are emitted, and it is creating the entire building or the shade area such type of problem, instead of going through the this type of ducting line, which is finally connected to the bag filter. This is another one. Here what you are seeing, that in a power plant, when dust particulate matters are collected at the top in the hopper, so from this hopper, when you open the valve, it will be loading the tractor. So in this tractor, from this hopper, solid particles or the solid mass, maybe the fly ash, will be loaded, and truck will carry say 100 meter, 50 meter, 100 kilometer, 50 kilometer, 20 kilometer away to the nearby brick manufacturing plant or the cement plant, just to utilize the fly ash to some of the plant. Unfortunately, when the charging of this fly ash is being done, you see the level of the air pollutant which are emitted, correct? So your stack is here, chimney, these are the bale conveyor, and this is the area, just like the smoke powder, it is nothing but the all dust particulate matters, right? So this is another example how with so much effort we collected the particulate matters and stored in the storage bin, but again from there it is now spreading to the our environment, creating huge problem to the vegetation, land, environment, and the workers, those who are working inside the plant or near the plant, right? So this is the example. You see, one truck is loaded, backside background is nothing but the forest or the that greenery is there, but you can't see because all smokes are coming, right? Those smokes are nothing but the all type of this dust, black particulate matters, and if these leaves of the tree are not visible, because I personally visited this plant site. So you can see that there is a huge coating of those dust particulate matters over the leaves also. Because if this is the quality of the air, you can imagine the smoke time, then smoke type, then it is quite understandable that how much quantity of the dust is emitted to the environment. I will show you something. Okay, so here if you see this is a sponge iron plant. This is the holder, I mean roller, through which the belt is moving upward. So when belt material is transported through the belt, this plant is under operations. You see whatever this smoke type of things is emitted, right? Just I showed you those smoke type of things is nothing but the fugitive dust emissions. So when the material is transported through this belt conveyor, you see here the rollers are visible. So when this roller will move slowly, rubber line, belt is made of some type of polymer or the rubber. It will move. So the materials also will be transported from the from the bottom to the top end. And these pipelines, you can see how dark it is and how much the concentration of the dust which are emitted. Look for the another example. Yeah, so you see this is another plant. Just now I show the picture. So in actual operations, right, you see how dust particulate matters, those are the flyest particulate matters, when it is charging. Can you imagine? You see people are behind that, right? We are also standing nearby there. So lot of dust particulate matters, you can see from this video how those dust particulate matters are emitted. Yeah, it is opening. Just wait for a minute. So if you see these pictures, it will be very clear to you that although we have the air pollution control equipment, oh my God, so it is not responding. Can you see this? Is it? Yeah, let me to stop it first. Is it visible? This video, is it visible or not? Hello, can anyone?
No, sir.
Oh, okay.
No, sir.
Video is not visible.
Yes. No, sir. There is no any video visible.
No, sir.
No, now it is stopped. But when I run, is it visible that video is playing? Yes or no?
No.
It is not visible.
No, sir.
Now?
No, sir.
No, sir. No, sir.
I think there is some problem then. Yeah, let me sort it out. Just wait.
Okay, sir.
Professor Micah,
Come again, please, sir. Hello.
better you stop presentation and
now is it
directly.
okay? Now is it okay? Now is it visible? Hello?
No.
No.
Sir, you stop presentation and directly on the screen of the computer you do it.
Okay.
Yeah, that screen, that's all. Unless you stop the presentation, it will not open, I think.
Is it visible or no? Is it okay? Is it visible or not?
No, sir. You do one thing. You click on your screen. Just you first leave the presentation. You go to the computer screen. What we are seeing, and then activate that.
Okay, I did that.
I play that.
I did that.
I play it from directly from your computer screen. I think then it will solve that problem.
No, it is not coming. Not yet coming.
No, sir. No, sir. You play that. You put your cursor on that and then play it one by one.
Yeah, I am playing it. Is it playing now? Is it playing now?
No, it is not. It is not visible.
No, sir. You can choose other multimedia player, sir. Window player is not. You can choose other media player, sir. Just like BLC player. Window media player are not supported this file.
But other slides you can see that other video you can observe other video. I showed 2 to 3 video. Did you seen that or not?
Yes, I have seen that, but not playing.
Or not playing, but I played this one. What happened? Okay, so now it is visible. Now is it visible?
Yes, sir.
Okay, let me to play now.
Yes, sir. Fine, sir.
Okay. So you look for this. Yeah. So this is a plant, right? So in this video, what are you seeing? This belt is moving continuously, right? This belt is moving, and from the top through this hopper, material is falling, and it should be taken away. It should be taken away a long distance. Yeah, it should be taken away a long distance through this belt. But unfortunately, this hood, this thing is also provided. The main purpose of this hood is just to collect such type of your huge particulate matter, right? It should go through this hood. So instead of going such type of particulate matters which are going near the plant area, which is nothing but the fugitive emissions. So these particulate matters are practically some of the iron dust as well as the slag material. So I mean, if you look for this concentration of this particle, this is your huge, right? So this belt is moving. The material should be taken forward, and these are the different curtains. And through this ducting light, dust particulate matter should go, and it should pass through the bag filter, and finally it should go to the stack or the chimney. You see this side of the belt, it is clean, but when it is moving to that side, there is a huge dust emission, huge dust emissions which are emitted from this plant. So this is known as the fugitive emissions, right? Let me to go ahead little bit. So is the movie is now playing? Can you see how much quantity of the dust is emitted? Is it clearly visible?
Yes, sir.
Yes.
All
Yeah.
fine, sir.
Okay. You see, reddish color, that dust, and this is the hood. So from everywhere, all the particulate matters are going. So what is the main problem? Whatever the hood we provided, that hood is not working proper. Why it is not working properly? Because the suction, which is negative suction, negative pressure, that much suction, it is not created by the induced duct fan which is connected with the bag filter. So all the duct is finally connected with the ducting layout to the bag filter, and then an induced duct fan, and finally it is going through the stack or the chimney. So this is how the particulate matters, it is going to the environment. This is one of the example I just showed it because I visited this plant and I took the pictures. That sometimes that what is the diagnostic issue, how we can resolve the problem. For that purpose only. And this part is the bag filter. You see, this is the bag filter. Yeah, and this is the stack. This is the stack. These are the duct line. This bent pipeline are duct line, and this part is the bag filter. So this bag filter is already connected to that particular hood which is mentioned here. Let me to go to the presentation now. All right. So what can you see the slide now? One slide is visible. Major reason.
Yes, sir.
Yeah. Okay. So what is the major reasons for non-compliance of the emission standards? Now, when any state pollution control board changes their stringent limits, that means how much particulate concentration should be at the through the stack. At that time, what happens? The industry personnel, they may promise something that okay, from 150 milligram per normal meter cube, it has to be reduced to suppose 100 milligram per normal meter cube. So if pollution control board is making such stringent limit without doing much changes in the process plant itself, industry people may say that okay, we will be able to we will comply that. But if you do not do any changes inside the plant, it will never possible to maintain such things. So that's why it is written that when State Pollution Control Board changes the prescribed outlet standard, that means more stringent limits, the air pollution control devices should accordingly be upgraded or retrofitted to comply with the stringent standard. But that does not happen in many cases. The industries try to manipulate the air pollution control system to achieve the standard. That may be one of the reasons behind it. Next, most of the air pollution control devices are designed for a typical range of the dust particulate matters, as well as the dust concentration or the dust loading, as well as its characteristics. When either one of such things is changed, that means if you are using the coal from different sources, the ash content of the coal will change. As a result, the ash which will be emitted is your different characteristics, different quantity. So that hampers the air pollution control efficiency of the air pollution control devices. In most of the cases, the manufacturers prescribe under capacity air pollution control devices from their marketing point of view. What does it mean? When I sell my product, right, I will say that IIT Kharagpur is producing best quality of graduate. When some of your professor from your institute, they will talk, they will say that, okay, institute XYZ is producing the best quality. If you go to the market, shopkeeper, they will always say their product is the best quality, right? So second factor is coming, cost. So if the quality is good, everybody is saying the quality is good. So what is the cost? You will find some rice is 50 rupees per kg, something 40 rupees per kg, something 30 rupees per kg. So depending upon your pocket, how much budget do you have, you can buy that. So similarly for the industry, as you know, that pollution control, environmental management, although it is the primary concerns, but sometimes industry may thought in other way. They may thought it is the investment, out of that we are not getting much. If the industry is small scale or medium scale, they may think that way because they have to do the investment. Out of that, only environmental management or the pollution prevention will be there. But if you see in terms of the profit, right? So increase in profit may not be visible, although there are many ways this profit can be visible, because managing the environment is the great, profit. Moreover, all the dust particulate matter, so it will be recycled, then also it can, include in the profit. But in the closed eye, people will thought that if I invest so much, there is no profit. So they will try to install the minimum, cost air pollution control equipment, and the manufacturer may say that, okay, my equipment will run fantastically. After you install, maybe after 1 year, 2 years, that air pollution control equipment will malfunction, and you will come to a situation that just I show you the video, that type of situations will come to our real life. If you have any question at any time, you can stop me. I don't mind, right? If you have any question, anything is coming to your mind, I will try to address that during my lecture also. No problem. So what are the factors affecting the performance? The factors affecting the performance, the most crucial is the capture velocity. So what is capture velocity? You know that say suppose when the belt is moving, lot of dust particulate matter is moving here and there. Why they are moving? They are not captured properly through the hood. So the velocity at which those dust particulate matter to be captured, allowed to pass through the hood and then to the ducting line to the bag filter, that is known as the capture velocity. So to get the capture velocity, what you have to do, you know what is the size of the particle, So if the size of particle is, say, suppose dp, you know settling velocity equations, isn't it? Settling velocity equation that ut, terminal settling velocity, is nothing but dp square into rho p minus rho g by 18 mu. So if the viscosity of gas is known and that dp, what is that, rho p, density of the particle in most of the cases also will be known. Rho g is nothing but the air, it is 1 point, maybe your 1.25 kg per meter cube. Density of the dust particulate matter, it will be very close to maybe 2000 to 2500 kg per meter cube. That means density of the gas will be negligible, and then diameter of the particle is dp square. So if you can calculate this ut, terminal settling velocity, you know at which velocity it's falling, right? If particle settling velocity is small, right, is very small, then what will happen? They will not easily settle down and they will be transported to long way, and it will create the environmental pollution. If its settling velocity is very high, when it will occur, if the particle diameter is more, density of the particle is more, then easily they will try to settle. So it will cause minimum problem to our environment. So whatever it is, if you see the average particle diameter, and if you calculate it, you will get some some terminal settling velocity. So 2.5 times to that of the terminal settling velocity will be more or less your capture velocity. That means the velocity, right, at which this dust particulate matters will be dragged and it will be allowed to force through the hood. So if we can maintain that much velocity, no dust particulate matters, it will go through the suction. All the dust particulate matters, they will come this way through the hood, they will go. The video what I showed just now, there you will find all dust particulate matters is going like this way, they are dispersing. But if we can maintain the enough suction, they will come together and then they will go upward, right? Upward means it will go through the ducting pipeline, then go to the bag filters where the bags are kept in, and finally after cleaning through the chimney it will go. But the video I showed here, it is not going at all to the air pollution control equipment, that means bag filter. So nearby the industry, the people's property, villagers, everybody is affected with this. So with this, any question do you have? All right. So how the hoods will be, look like? You see, this is the simplified diagram. Can you see some ducting layout I have shown here? Is it visible? Ducting layout. Is it visible? Ducting layout. Hello? Can you see my slide?
Yes, Professor Michael, it is all right. You carry on.
Okay. So here, if you see this part, this is nothing but our hood. These are the different type of ducting layout, correct? Then it is going to, this is our bag filter unit or the bag filter system. So 1, 2, 3, 4, just like these hoppers are there. So this is known as the hoppers of the bag filter, and this rectangular shape is nothing but the compartments of the bag filter. 1, 2, 3, 4 is there, and then this is one fan, just like motor or fan type of things you are seeing it. This is nothing but the induced draft fan, or in short it is the ID fan, and it will be connected to a stack or the chimney through which the gas should go. Now, if the dust particulate matters very close to the hood is not captured, just like the video it is going out, then you will get the very clean gas from the stack, nothing will be emitted. You will find that stack is very clean. That means in blind eye, people will thought that this industry is very good, nothing is emitted to the environment, but truly not, because near this hood, lot of other particulate emissions, everything is going to the environment as well as the industry. So that is the fugitive emissions. Now, if your ID fan is good enough, it can create enough suction near the hood more than 2.5 times the capture, 2.5 times the capture velocity, then all the dust particulate matters now will pass through this hood. They will travel through this pipeline. Then all the particulate matters will be collected by the bag filter or the bag houses on the wall. Dust particulate matters will be collected at the bottom in the hopper, and you will get very low concentration of the emitted gases through the stack or the chimney. So what is needed? So based on from IIT Kharagpur side, I personally visited more than 100 such type of sponge iron plant, right, throughout the your Odisha state. And not only that, I visited the plants in Chhattisgarh, even in West Bengal also. So final concluding remarks after visiting the plants is like this. After detailed engineering calculations, right, you need to do how much pressure losses are there in the ducting pipeline, how much velocity should be there, what should be the that cloth area. We have come following points: that capacity of the ID fans should be increased to as suggested with 50% extra capacity, just to avoid any fluctuation. Number two, number of bags is to be increased if air to cloth area ratio, which is known as the air to cloth ratio. That means how much air and how much cloth area. What does the cloth area mean? Cloth area is nothing but this. Say suppose if I reverse it, then you will find this is a bag filter. So cloth area is nothing but this surface area, right? Pi RD, and this top surface area, more or less it is pi R square. So this is the surface area of a single bag. If there is 500 bags, then 500 into area of one bag will give you the cloth area, and how much ID fan capacity from their air volumetric flow rate is known. So air to cloth ratio will be known to you. Near hoods, the covering with rubber sheet between the gap of hood and belt is essential. Now, many cases what happens when the hood is belt is moving, the curtain or the what is that? This area maybe is your open, or sometimes some poly that cement bag is giving. We have observed that. So those type of things should be avoided. Hood must be covered with proper apron. That means rubber lining apron. Rubber line means it will be more or less 3 to 4 mm thick rubber line. So it should be completely covered. With width is the same as the diameter of the belt, and length 2.5 to 3.5 times belt diameter. That means little rectangular shape. Hood apron should be covered with this. After collecting the dust particulate matters, as you know that lot of dust particulate matters are again going to the environment, right? From the hopper, sometimes through the pipeline, it will come to the where the dust particulate is stored. That is not the good idea. So pneumatic transport of the collected dust to a silo shall reduce the fugitive emissions. That means by fluidization in presence of the air, it will be carried out all the dust particulate matter to the silo. It is not any sort of truck or lorry or the dumper, nothing, no manual intervention. Through the pneumatically, through the pipeline, all dust particulate matter has to be taken to the silo. If it is so, then we can minimize this fugitive emissions. Okay, so this is about my first one. Sir, how much more time I will get? Accordingly, I will try to complete it. Another 30 minutes.
Sir, your timing is up to 6:30.
Oh, excellent, excellent. All right, I will be able to complete, no problem. Now, next I am going to, that electrostatic precipitator, its challenge. That means in situ generation of the ammonia for flue gas conditioning in thermal power plant, right? Now, in thermal power plant, what happened? Highest particulate matter is being emitted through the stack. due to the variations in the properties, that means concentration, etc., as well as the dielectric properties of the fly ash, sometimes performance of the ESP may not work good. So this is just to give an example that this is the discharge electrode at the center and this is the collecting electrode. So when the particulate matter is being charged by this electron, then they will go to the discharging electrode, because almost 60,000 to 90,000 volt will be applied between this collecting electrode and this negatively discharged electrode. So as a result, particles will be charged and they will go to the side. They will go to the collecting electrode. But sometimes this is the typical view of the electrostatic precipitator, how it looks like. And this picture, this that maybe thread type of thing is nothing but the discharging electrode. All right. So these are discharging electrode. This entire device, entire compartment is nothing but the electrostatic precipitator. This is the inlet duct of the electrostatic precipitator. It may be one man is standing here, so minimum it will be 3 times. That means 15-20 feet is the height of the inlet duct of the electrostatic precipitator inlet duct. And these are the bottom hoppers which are connected pneumatically to send the dust particulate to the silo. Okay, and this spring, whatever you are able to see it, this is nothing but the discharge electrode. So electron will be discharged through this when a very high voltage, almost 60,000 to 90,000 volt will be applied. And these are the arrangement to hold the electrode. So with this, like this manner, it will be hold. So this is the structure, and this is the collecting electrode, how it will look like, and this hole will be just fitted in the previous structure where it will be hinged properly, and these are nothing but the collecting electrode. Okay, so these are the spoil collecting electrode after its life is lost due to the your many regions deformations, many things. This is the waste or discarded collecting electrode from the plant. So coming to this point, when flue gas contain the fly ash particulate matter, what happens? That fine particulate matter may not go to the collecting electrode. So what is being done? Ammonia is being injected with the flue gas. So we had a project with National Thermal Power Corporation's NTPC. So here ammonia will be injected with the flue gas by making it in situ from the urea. So ammonia with sulfur trioxide, which is present in the coal contains some of the sulfur. So sulfur plus oxygen will form sulfur dioxide. Sulfur dioxide then will be converted oxidized to sulfur trioxide. Sulfur trioxide with ammonia, it will form ammonium sulfate and ammonium bisulfate. So those ammonium bisulfate and ammonium sulfate in small nuclei, what they will do? If this is a fly ash particle, maybe 1 micron, 2 micron, over there some dot nuclei of ammonium bisulfate or ammonium sulfate will form. Once it is formed, these are hygroscopic in nature. So two particles will come together, they will agglomerate, particle size will be more. Then the resistivity of the fly ash particle will be enhanced due to the deposition of the coating of this ammonium sulfate. So if the dielectric properties of the fly ash particle is enhanced, then we will be able to collect it more easily in the collecting electrode. So ammonia is used here is just like a conditioning agent. It will give some conditioning of the particulate matter so that now they will go towards the collecting electrode very easily. That is how it is being done, and that is the main mechanism behind flue gas conditioning, how it helps to collect the particulate matter from the flue gas of the thermal power plant. Right. So these are the different type of reactions. Ammonia is very hazardous and dangerous to store it. So it is essential that you manufacture as much as you want. So in situ generation of the ammonia, you need to make it For that, we use the this urea hydrolysis. So if you do the urea hydrolysis, urea is very easily available, right, as a fertilizer. So if you hydrolyze it, it will first form the ammonium carbamate, just reverse of the ammonia production. So you do it so that we will get the ammonia and the carbon dioxide. This ammonia will now react with the water to form ammonium sulfate, ammonium bisulfate, and your main purpose will be salt. This is the reaction experimental setup what we did at our IIT Kharagpur. So I will show you the picture if I have. Yes, this is the picture of the setup. This is a 200 pressure, high pressure reactor with star all type of arrangement, which is connected with a control panel. So everything is controlled through this control panel, and we have the feed storage tank, and this is the urea feeding tank. We are feeding this urea through this reactor, through this path, and the vapor, I mean ammonia, which is being generated from here by hydrolysis, is being condensed here. Then it is being collected here at the bottom for that purpose. And these are the some of the findings, how the conversion by time, that means chemical kinetics, chemical reaction engine will come to the picture. Those things are presented here, but for the general reader, I am skipping it. If you are more interested, at the bottom some reference paper is giving those things you can go through, or even you may contact me if you require. So I will skip this results finding. Next is the that weight scrubbing techniques for the control of air pollutants. So all the air pollutants may be removed by using the so many type of the weight scrubber. One of such weight scrubber is the multi-stage bubble column weight scrubber, where we have used two type of disc, internal disc. So if you are using this type of internal disc, one is the rupture disc, another is the expansion disc. So without much energy loss, we will be able to break the bubble, make many interfacial area, and you will be able to capture it. Just go to the next slide so that you will get a very clear picture. So this is a multi-stage bubble column scrubber. So what is being done at the bottom, dust, laden particulate matters at the gases is being dispersed right through the distributing plate. So you are getting very small bubbles. Then what happens? There is one, this bubble size will increase, right? They will form the larger bubble. Once they are moving upward, then there is a rupture disc. That means small opening disc. So through the small opening disc, if the large bubble is going to pass it, what will happen? It will break up. So what is the funda of the breakup? If this is a big bubble, from the surface, all the pollutants are going to the aqueous phase or the water phase, where some chemical reactions is taking place. But that inside the bulb, still the concentration of the pollutant is more. So they are not, because gas phase resistance is much more than that of the liquid phase. So inside at the center of this bubble, the concentration of pollutant is very high, and inside this bubble they are that maybe concentration gradient is your huge in comparison to that of that surrounding. So once this bubble rupture, then what happens? Inside particulate matter and air pollutants that is now exposed. So they are coming into contact with the water. Part of the things will be again absorbed, which is being done here. Once it is done, then it is the guiding disc. Okay, this is the expansion disc or the guiding disc. We are making it a larger bubble. So if it is making a larger bubble, that concentration of the gases inside the bubble will be uniform. Once they are going again to the rupture disc, again they will break down to the many small bubbles. So by this mechanism, what we are going to achieve? We are trying to increase the number of new surface area generation, renewal of the surface area is created. That means you are getting more and more surface area. If you see the overall mass transfer coefficient area, that overall amount of the pollutant which is being transferred to the water phase is nothing but KLA into the concentration difference. This KL is the liquid side mass transfer coefficient. We do not have mass control, very limited control over there to increase or decrease. But A, small a, which is nothing but the interfacial area of the contact, meter square per meter cube volume of the, this water, how much new area is being created. That thing we create, because this is the mechanism by which we are creating. If we create it, then small KL into A is nothing but the overall mass transfer coefficient K. That value is increasing, and we will be able to capture much better way what is being done. So we have, this is the experimental setup and some of the research finding which we use to remove the sulfur dioxide as well as other gaseous pollutants, that means particulate matter together. Next, this is another system where at the bottom, আমি একটা মিটিং আছে, I will call you later. আমি অন্য একটা মিটিং আছে, একটু ব্যস্ত আছি. So here what happens, we have the two column. One bottom section is the spray column and top is the bubble column. So in the spray section efficiency is generally low, 70%, but in a continuous phase bubble column the efficiency is more. So at the top we are doing some polishing work, and at the this side we are capturing the most of the dust as well as the gaseous pollutants. So such type of devices also we have, right, in our system, and this is the complete setup, the pictorial view of the setup what I have shown. Even sometimes we are using several type of the internals, those who will try to help because they will give some impact. You see this type of inclined battles are there. So those inclined battles, what we do, so if it is a inclined battle like this manner, inclined battle is kept like this manner, that upcoming gas, contaminated gas will hit here, and then they will try to move downward. As a result, their capturing will be more, because the inertia what it is giving, that will be obstacle by this type of internal, and we can get the more efficiency. We did some results also we had. With this I think we should skip this thing, such type of results. This is another interesting cover which is very common. You might have heard the name Venturi's cover, but normally what industry they used to do, normal Venturi's cover. That means through the venturi the gas will come at the throat, the velocity will be the huge, then it will be expanded, then it will be coming. So by using this we can control the various type of particulate matters, gaseous pollutants, that is correct. But if you remember one of the accident which happened in the nuclear power plant of Japan, Fukushima in 2011, where huge nuclear waste material, contaminated gas, radioactive material was released due to the explosion of the nuclear reactor. Why this was happened to that all the there was a complete electric current failure, all pump valves, everything was failed. So there was a close of the water line. So if there is water line closed, then there will be no cooling. Whatever the gases stream is coming, they first broke the main core of the nuclear reactor, then the secondary wall, and it was a complete nuclear disaster. Now to prevent that, what we made complete submerged type of the Venturi's cover. You look at here. So this is the Venturi's cover, right? And it is in-house in an outer periphery of the column, perspex column. So this is the throat. This one is the throat. So if it is submerged condition, then what will happen in the event of complete power failure? When some contaminated gas is allowed to come, then those contaminated gas will come through the venturi, and since there is a high velocity of the gas, there will be a creation of the suction or the vacuum. So since our water is completely filled up to this water will go inside dust particulate matter, as well as the water, it will mix up. Then at the bottom, they will try to settle it. Correct? Now, if with the time, what will happen? After 1 day, after 1 week, after 1 month, what happened in Japan? At the beginning, flow rate of the gas is huge. Huge gas is coming. So the suction velocity is huge, like this manner it will come. It will suck the water. After 20 days, the velocity of the gas will be reduced. So just like a small, flow rate of the gas will come, this water will come very low quantity, because volume of the water, temperature has come down, volume of the gas is low, and you're slowly in a self-sufficient manner, this type of complete summer venturi scrubber can tackle such type of problem in the real field. Okay, so yeah, these are the some of the results, that what percentage of the that we conducted the experiment from hydrogen chloride gas, even for particulate matter SO2. So those results are given here, and this is the complete individual setup for the individual 5 years removal efficiency. Yeah, you will skip this. Now I am coming to my last part of the talk, that means pollution caused by coal-fired thermal power plant. So actually what happens, that background of this work is that Chhattisgarh Environment Conservation Board, that is nothing but the Pollution Control Board of Chhattisgarh, was directed by the Bilaspur Honorable High Court that why the power plants are causing so much pollution, what are the prevention methods, how that can be minimized, so that our main purpose, that means power generation will be uninterrupted, but at the same time pollutions also not cause any problem to the local people, because there is a lot of complaint, etc. So as per the directive of the Honorable High Court of the Bilaspur, that work was given to IIT Kharagpur, and I was the in charge of that particular. So I visited number of thermal power plant to give some suggestion that how, right, this, what are the to study the pollution cause and need steps to be taken to improve the pollution situation and to ensure that pollution is reduced to minimum level without affecting the generation of the electricity of coal-fired thermal power plant of certain region, Janjir, Chiapa, and Raigad region of the Chhattisgarh. Please look here, two aspects is there. What they said, that we should generate the electricity, we cannot stop it. We are stopping the electricity, our daily life, everyday life, everything will be stopped. So that is not possible. So our society will go a few years back, few decades back, if our electricity generation is stopped. So electricity generation should be there, but at the same time, pollution should not cause any problem to the environment. So we did a detailed survey of all the thermal power plants located in that area, and we come up with some solution that what the methods we can minimize it. So I will see some of these photographs, just have a look how they are creating the problem, then we will come to the recommendation. Correct? So this is a thermal power plant. If you see, this is the cooler, your cooler, and this is the your this one. What this is the cooler means cooling tower rather. These are the bell conveyor, and this tall stack, which is 275-meter stack or the chimney. It is one of the thermal power plant, and this is the ash type which is constructed. Correct? So you will find that ash type will be similar to this very big pond where fly is being dumped in the form of the slurry. If you look it, these are the pipe. Through the pipe, slurry has come, and this big vast area is nothing but the ash pond. And these two is the cooling towers, very big, tall cooling towers. Now this is the, you see, this is the actually charge. Can you see the video is running? Video ran or not? It was running video.
Yes, sir.
Yeah. So here, if you see, this is the silo, and during the loading, you see how much quantity of the dust particulates are being emitted to the environment. This is one of the power plant. All right. Yeah. So this picture also I showed. This is for the thermal power plant picture. Correct. So during the loading period from the silo, this is more or less the common, common phenomena in more or less every power plant, where from the silo this dumping loading area is there. You see at the bottom how much quantity of the solid residual dust etc. is lying, which will indicate, because if there is a wind, storm, even at normal conditions, those will be emitted to the environment, and it will cause a huge health problem to all of us, right? So these are the pictures how this is being generated. Okay, so here what you are seeing is that at the bottom, yeah, if you go here, yes, if you come here, you see that slag, molten iron slag is coming, and entire shade area is full of the dust particulate matter. You can see how this area is completely full of the dust particulate matter which are emitted to the environment. And let me to go slowly. Yes, here you see everything is connected to the bag filter. This is the bag filter, and this is the belt conveyor, and this is the main chimney, and this is the ID fan. So although the bag filter is there, but this is the scenario. Let me to go to next one. Yes, I have shown this thing. No, yeah, I have shown this. Yeah, I have shown this thing. So these are the different silo, and from there how that dust particulate matters are emitted to the environment. And if you see the plant, this is another plant. You look how what is the total quantity of the dust is emitted to the stack, and this entire plant area how the dust is, and this plant is almost died. The concentration is so high, right? Very pathetic conditions. This is also one of the thermal power plant which I visited. Correct. Then you see this is a typical bag filter. This is the bag filter, right? Entire plant is there, and these are the ducting layout. You see this area is full of the dust. Small few megawatt power plant, but still you will see at the ground level how what is the conditions of the different type of dust particulate matter. So I will come to some of the recommendations which may be helpful to understand that how to minimize those dusts in the coal-fired thermal power plant, right? So similarly, this is the area, right? You see how the dust particulate matter they are connected. I have just to make it understand, I have shown you the various pictures, so it will be here for you. Now coming to the recommendations. So finally, we recommended that in the plant area, all the dust particulate need to be collected and properly collected every day, and they should be disposed, which is in single term is known as the proper housekeeping. Telescopic silo loading with loading chute completely set against the mouth of the closed container should be maintained. That means when from the silo something is coming, some that tube, it should go to the that loading truck or the dumper, so that nothing will go. Industries with old boiler that is not capable of handling the highest coal to use retrofitting to reduce the emission from the plant is needed. Filling of low-lying area by gas may be limited up to the ground level, because if it is above the ground level, then there will be a lot of pre-emission of the dust. And immediate soil lining may be provided for the small plants. Coal handling plant fugitive emission needs to be lowered by water sprinkling system or other dedusting units, as disposal may preferable for the mine filling. Government has to take the initiative to supply washed and clean coal or the lowest coal to the power plants. All PWD, pitch or concrete roads need to be maintained and cleaned regularly which carry either coal or ash. Beside the coal-fired thermal power plant, there may be many other small industry. They also should take care of it. All coal-based power plant operate fly ash brick plant must utilize the fly ash as its maximum capacity. Pneumatic transport of the ash may be tried in the hoppers. Plant which do not have waste heat recovery boiler from flue gas must install it. So those are the some of our recommendations. So finally, I am very much thankful to management and organizing team of this webinar, Faculty of Engineering and Technology, Jadavpur University, and Vivekananda Institute of Environment and Management, Kolkata, for invitation, as well as to share some of my real life, experience among you. I will be happy to take few questions, because that is my primary goal, not that I should talk all right. So thank you very much. Thank you all.
Thank you, Professor Mekam. I request the participants to present their questions either in chat form or in orally. Sharon, do you have any question? Sharon? Kausar?
Yeah, ask me. You should ask me. Free, friendly. There is no problem. Anything you can ask me. Right? I will try to address. Everybody's mic is muted. Those who are talking, please unmute it and ask me the question. Go ahead. I think either they do not understood what I taught, what I talk about, right? Or they are so shy to ask the question to me.
Anyone? So tell me certain operational things. That means what the way you are proceeding.
Yeah.
You see, apart from our monastery, I am also attached to one self-financing institute of Kolkata as a professor of chemical engineering. So what we felt that, while doing, actually I worked means my association with NIRI, the Kolkata Journal Center, and also with that Nagpur, the NIRI headquarters. Actually, in this program on 29th, NIRI director will also be addressing the apex body of the pollution control.
Okay, good,
India.
Good. Yeah.
So the thing is that I have found that starting anything, such type of things, I go to NIRI laboratory, there I work. But in our own workplace, how can I start all such things? In a small fashion, in a pilot project type thing, because we got some of the instruments. We got our, for example, GC, UV, and other spectrophotometer and others from the ACT funded projects, HPLC. But the type of things, equipments, what we require, for example, marker analyzer. So that unless we have such type of equipment, we cannot proceed.
Yeah.
So regarding this, can you have any advice? I mean, regarding.
Yeah, let me to address this. So whatever the work I showed here, we do not require, I mean, many more sophisticated instrument. If you see the problem of any industry, you try to, I mean, you need to apply your engineering knowledge. What is the cause of the problem and how to solve it? And if we simply do that basic energy, material balance, and the pressure losses, many things we will be able to do this. I fully agree. Some instrument is required when we are going to industry and measure it. At that time, some basic instrument equipment that is always required, because without that, right, we cannot proceed further. But if you need sometimes some help from IIT Kharagpur, because we have the that very good research facility. Sometimes we use it to find out either the mercury or to monitor by using the high volume sampler or the PM 2.5. So all sorts of equipment we have, that is a benefit for us to do such type of to solve the problem of the industry. So if any industry is approaching to you, if you visit the industry, right, they do not have the time. What is the cause of this, right? So you people may be able to diagnose something and give some recommendations so that some of the majority of the problem will be solved.
Okay, thank you, Professor Michael. Any other questions from the students? Ashanenduda, you wish to put any question? Ashanenduda? Mr. Mandal? No, probably he is.
Yeah, his mic is muted anyway.
Yes. Okay. Sir, here is one submission. Actually, what we are planning is every year our Vivekananda Institute has a very big function. In fact, that is our we have the small projects and other things, the societal projects also. But our largest spiritual function is on 12th January, Swami Vivekananda's birthday. This is Vidhannagar's, you can say, the very gala show as per our small town, the Vidhannagar is concerned. So, and every year it is being done in the EJCC, the Eastern Zonal Cultural Center. The center is being provided by Government of India. And I think last around 15 years, this tradition is going on. So this year, because of this COVID situation, we are keeping both the online and also offline the way that we used to perform the function earlier years. So that facility is there. So my idea is those can join offline means physically. So all the resource persons we will invite, so that we can felicitate them, because we could not do anything. All the research persons, they are really the important, scientists and academicians. So naturally to felicitate them, if it is possible. If it is not possible, then the small token of felicitation gift I will send to the addresses. But if it is possible, they can join, and then they can have the Sri Ramakrishna's prasad and the khichdi and other things. And also the participants, I am requesting that if they come, if they say that I will come, just by sending a mail or something like that to us, then we will arrange their food and everything, and also hand over the certificate to them. By this process, the one-to-one interaction will definitely increase, because in summer and other times we will have more such type of interaction program. Academic program, not only the spiritual program, the academic program. So that is the idea.
Good. So we'll see that. Let the time come, right? If it is there some opportunity is coming, I will definitely try, but I cannot commit at this point. Very good idea. Thank you very much.
You are also the in charge of this Kolkata IIT center. So naturally, you can make it an official duty. Okay, sir.
Okay, thank you. Namaskar.
Devalina has joined. Devalina, our next speaker, Devalina Sengupta from Texas University. She was alumna, prominent alumna of Jadavpur University. She will be speaking.
Yeah. Please. I should leave now. Okay. Thank you very much. Thank you all. Yeah.
Okay, fine. Yes, Devalina.
Yeah, give me just a couple more minutes. I'm just putting one
Okay.
thing. Sir, one thing I wanted to ask, can we share any documents over the chat here?
I think so. If you wish, you can. That is not a problem.
I don't know if we
things
can.
are very transparent, you see. Yeah. Nothing very, I mean, we are
No,
very informal.
I'm just trying to figure out if we can do it or not. If not, I'm just going to put it up on my Google Drive and then share that. Okay, so that's the thing. So today I'm going to try something new. And because there were also faculty in the group, what I will be doing today is a flipped classroom model. So let me just, okay. Give me just one more minute. Okay. All right, let me share my screen. I'm sorry, I'm sitting in the dark, so you won't be able to see my screen. So how, okay, we have about 24 participants today. So today what I'm going to do is, let's see. So the topic for today is a very unique topic, and there is no best way to teach design other than trying to learn it ourselves. So what I'm going to do today is, so the topic for today is sustainable design, and how do we design for processes? That is what the message will be from today's class or today's lecture. But design is a very hands-on experience, and currently we are working from completely different parts of the world. So I will use the method of flip the classroom lecture style. So how many of you have heard of flip classroom lecture style? Is there a way I can see some show of hands or yes or something? You can raise your hand if you want.
In our heritage, we have this methodology. We practice it.
Okay.
I mean, we adopt this methodology.
Okay, great. So that's great. So people have some exposure to this. So today what I'm going to do is I'm going to send everyone, let me see, a paper on design. This is a paper by one of my students and myself and Professor El Hawagi. And this is Sustainable Process Design Approach for On-Purpose Propylene Production and Intensification. Now, what I understand is that all of you come from different backgrounds, but this paper is very easy to follow in what we are doing. So I'll give you this overview. So this is an on-purpose propylene production. On-purpose propylene means that you are able to produce this when propylene demand goes up. You are able to produce this and ramp up production of propylene using this technology. In this, we have propane feed coming in. You have a depropanizer column. From there, you have some reaction scheme. You have a separation scheme. And then you have a propane-propylene splitter where you split the propane and propylene and you get the final product. You also get hydrogen as a byproduct of the system. So overall, this is a well-known process. There are different technologies that are available to design on-purpose propylene. And some of them are propane dehydrogenation methods, metathesis, and others. So our purpose was to design the propane dehydrogenation process, PDH. Now, you are given about an hour to read, ask questions, and send a 100-word review of what you understand. So it's very simple, very small amount of words. But you read this paper. I'm going to send you the link for this paper, and you're allowed to ask any questions during this 1 hour. And then we are going to have a discussion on either through the chat or through showing up or questions so that we understand whether you've understood the concept or not. Okay, so this is the flipped classroom method of learning. So let's just I'll send you this link and let's get started. Any questions? I think we are going to have great summaries. I'll stop the share for some time. And please let me know if you're able to access the paper.
Ma'am, it is saying access is denied. And
Try
it is.
once more.
Yes, ma'am, it is working now.
Okay, great. So I will be here, and any questions that you have navigating and trying to understand what the paper is. Maybe this is the first time many of you may be looking at research papers. So if you have any questions regarding that, let me know. Are there any questions? If there are any questions, please do ask. All right, as everyone is hopefully getting finished up with the write-up and sending it, I will go ahead and start the lecture. We had about an hour to go through the paper and understand what's the concept and the theme behind the paper and the work. So we are going to get started with the lecture itself. And the way I'm going to do this is I'm going to walk through the paper and we are going to learn the concepts of sustainable process design. So let's see. Okay. So this paper was about an on-purpose propylene production. We have an increasing spread between supply and demand curves for propylene, for which the aim is to investigate a sustainable process design approach for on-purpose propylene production. We follow established technologies to directly produce propylene. We have propane dehydrogenation, metathesis, methanol to olefins, and methanol to propylene. So MTO or MTPs. The flow sheet for this work is very generic to any process design that we do, except for the last parts where we have several different options of adding many different things. So So we start with assessing our process alternatives. As I mentioned, we have different process alternatives of propane dehydrogenation, metathesis, methanol to olefins, and methanol to propylene. We have feedstock candidates. So propylene or any other chemical can be produced from different feedstock. There are different chemical pathways that can be taken for producing the product. And then there are feedstock and product costs that are information that we require. So these are the things that we start with for process design. And we create a process data inventory. We looked at some of the life cycle inventory. So sometimes this can be similar. So we have a process data inventory that we create. Then we start with stoichiometric economic targeting. So when we do that stoichiometric economic targeting, it's a very simple method in which we can discard certain alternatives very quickly without getting into detailed design. So the issues that come up with process design is that you have a lot of alternatives that you can choose from. And some of the early stages of design decisions can impact your future process design significantly. So it is very important for us to understand and learn what are the best ways in which you can discard alternatives which are not going to be viable in the long run. So that's a very important step and a very strong method of looking at stoichiometric economic targeting. After that, we do a process simulation of base case design. Students who are probably in their final year, they have already started their senior, like the final design. So the base case design is something that we all need to do. And the better we can make the design from this base case, the better our process will be. So the components of process simulation of a base case design is mass and energy balances, equipment sizing, figuring out what the best optimum operating conditions are, using some utilities, designing your utility systems, which includes steam, cooling water, as well as any other energies. And then look at the wastes, what to do with the wastes that are generated. So if you look at any generic process, all of these are common to any generic process, like chemical conversion processes that we do in the industry. And then we have, this is a part that we do not typically teach in undergraduate courses, but definitely this is of very much importance. We do teach process integration at Texas A&M University. But process integration is a powerful method in which you have specific graphical or algebraic methods to integrate your energy and your mass within your process system. So what does integrated mean? Integration is the way in which you can minimize your losses and you can maximize your output from a system by making use of your hot streams and cold streams. For heat integration part, you can make use of your hot streams and cold streams, and you can capture the energy from these hot streams and cold streams for each other instead of using fresh utilities. So that is what process integration in heat is about. Process integration in mass is a little bit more complicated because in mass, you're not only dealing with the heat content, but you're dealing with multiple species. So heat is one attribute, but if you have mass flow streams with multiple components, then the separation and reutilization or recycling of those mass components becomes a little bit cumbersome. So the best option is to go with a detailed and step-by-step method of mass integration that is used for process integration. So there is a difference between mass and there is a third type of integration method, which is known as property integration. So mass integration typically deals with the entire flow rate of mass, whereas property integration deals with the components such as density or composition or some other aspects. And that is typically known as property integration. So process integration typically has three different methods: mass integration, heat integration, and property integration. So apart from this, there may be a third like category or fourth category that you may consider, which is energy integration. But typically heat integration is the over-encompassing part of energy integration. After process integration, you go into the integrated flow sheet process simulation, where you do a detailed techno-economic analysis. You do environmental and energy analysis, and for this you need to have detailed cost data and environmental and emission factors and life cycle assessment data and models. So the LCA data and models that we learned yesterday, these would go in doing this integrated flow sheet process simulation and energy and environmental analysis. So that is where the LCA comes in. And the techno-economic analysis is doing it in our standard procedures. Finally, we have multi-objective assessment and the final technology selection. And then we do the design recommendations so that it can go for the third stages of design, like the detailed P&ID and all those things. So all of these these steps that I have mentioned, they go into your front-end engineering design. So that is FEED, feed. So feed design is very critical, as I mentioned, that once you have made certain choices, you have to stick to those choices, and it is always wise to have as much of front loading of options and choices and methodological and methodical ways of selecting your process, the better it is. Because once you have made a design recommendation, you stick with it because you have already invested a lot of time, effort, and energy. So typically process engineers or chemical engineers or mechanical engineers or whoever, they, as they graduate as students, if they graduate and then they go into the industry, they will typically start with some part of this front-end engineering design if they're going to work for a design company. And having an understanding and knowledge of these typical, like these advanced process design methodologies will help in the future if you're going for any interviews or other opportunities. So if you learn this, it's going to help you in the long run by helping you understand the different steps that are involved in this. So here we go to the first step of stoichiometric economic targeting. So you do an MISR, you'll see the acronym, it's given in the paper. So you do a ratio of annual production rate of product and purchase price of product over annual feed rate of reactant times purchase price of reactant. And once you calculate these using the data, you see the paper says that propane dehydrogenation has a value of 2.07, olefin and methanol to olefins have 0.95 and 0.98. So the rule of thumb for MISR is that if it is greater than 1, then the process should be chosen. If it is less than 1, then there is not enough profit to be made. It is already in its loss because the price or the selling price of the product is less than the purchase price of the reactants. So if your selling price of the product is less than the purchase price of the reactants, common sense tells you that you're not going to make any money out of that process in that scenario. So here you see there are two primary variables that really are determining this, which is the price of the product and the price of the reactant, because your feed rate of reactant and production rate of product is not going to change significantly unless you have some design changes or details, that information that you have. But just based on the price of the reactant and the product, you can determine whether your process is going to be profitable or not. If those prices change, then it may become profitable. So let's say the price of reactant goes down so low, and that we have seen pretty much with all our all our reactants and products. For example, you have gasoline or crude oil prices have gone between $20 a barrel to $140 a barrel over the past 15 years. So we have seen that price of reactants can change significantly. So anyway, so based on that, you make the choice and you understand that your propane dehydrogenation is a method of getting your propylene. So once you have made that decision to go with PDH, you go into the process simulation base case design. So this is a base case design. Nothing has been done other than looking at the routes that you require for separating the propane feed, extracting the propane, going into these 4 reactor scheme. There is a reason for why you have 4 reactors. If you read the paper, you'll get to know. Each reactor has a different conversion, so it is allowing you to convert as much propane as you can before you send it through a reactor effluent compressors and coolers. And then you do a heat exchange in the cold box, and then you send it to your SHP reactor, which is your sulfur removal. And after that, you have about you send it to a de-ethanizer, because ethane can be a byproduct from this system. And then you send it to your propane propylene splitter. So the propane propylene splitter, you'll see, is one of the major equipment in this process, mainly because it is a very large unit. If you, I didn't have the video, but I can send it. If you look for Dow chemical propane propylene splitter, you'll see it's one of the largest propane propylene splitters in the world that was installed in Freeport, Texas. So after you do this propane propylene splitting, one of the reasons that you have a very large column is that is because propane and propylene have very close boiling points, for which you need multiple trays to separate the propane from the propylene. So once you have the propylene as a product, then you have a recycle stream, and the propane goes back into your propane feeder. So this is your overall schematic. If you do a analysis of the energy use and the utilities, you see that you have consumers in the process, and you also have cooling water. So you consume steam, low pressure steam, natural gas, electricity, and cooling water. These are your process utilities. Now, what you see on the right bottom is a composite curve of trying to do the heat integration. I'm not going to go into the details because these are very complicated concepts, but you understand, you look at the figure and you see that there is a gap, and there is a lot of like the red curve and the blue curve, they have a lot of space that is common to them, which when we look at the integrated curve, you'll see that that changes. And this is a visual way of representing the heat integration. So you have heat flow, and you have temperatures, and you use this method to determine how much you save, you can potentially save. So these are all the hot streams and the cold streams combined, and they are represented in this diagram. So now we are going to look at the process simulation. We have done the process simulation of the base case design, and then we are going to look at the mass and energy balances, equipment sizing, operating conditions, utilities, and wastes to do the process integration. So there are three different cases that I've shown here. You start with the base case, which is completely unintegrated design, no major information other than stoichiometry. The second stage is the integrated case, where you have process stream heat exchangers. So here you have some hot streams and cold streams, and you just use heat exchangers. Like here, we have a heat exchanger, sorry. We have another, excuse me. We have some heat exchangers here. We have another heat exchanger here. So we use those heat exchangers to recover as much of energy as we can from the process streams. So this is, again, you can make this understanding, you can understand where these heat exchangers need to be placed by looking at the process energy available. Then you do an integrated case and intensified case. Once you have done this heat exchanging with the process streams, so this is stream exchanging, even after that, you can see that because of the properties of the propane and propylene, your column is very tall, and it is so tall that it is very difficult to even install that column. So you have a heat pump added to the propane propylene splitter. And a heat pump is a combination of pumps, heat exchangers, and compressors. So here you are using the property of electricity as an energy source rather than heat as an energy source to see if you can compress, and you're trying to change the properties of the fluids that you're dealing with to do an integrated case and an intensified case. So this is changing the process equipment rather than the process streams that we did in the previous case. You're changing the equipment properties, or making use of the equipment-based properties to make a change in your process, overall process. So that is an attribute of intensification, process intensification. And in this way, with the intensified case, you're able to reduce the size of the propane propylene splitter, and you're also able to reduce the overall cost of the units that you had. And even after that, even after this case, we see that there are some streams that still have some value. So waste heat recovery and off-gas recovery. So waste heat recovery is, so integrated case, intensified case, there is some waste heat that is coming out of your output streams, and those have not been integrated before. So you can do some waste heat recovery, and you can do some off-gas recovery by burning it as a fuel. So if you see here in the stream, you have a C42 fuel. So C4 plus is, it's a waste from this process, but you can still, it has a heating value. So you can heat it and you can recover it as a fuel. So these are three different cases that you have seen in this process flow diagram. And then you go in and do your capital cost estimation and your operating cost estimations. You have comparison of different cases. You have the base case, you have the integrated case, and you have the integrated and intensified case. And you calculate the capital cost. You separate it out by the section, so it's easier to see where your energy hogs are, where your process stress, you have to stress on which process, like the reactor section and the splitter section as anticipated has the maximum of the capital costs. You can also look at the operating cost. The splitter section had a very high operating cost, but when you went to the integrated and intensified case, the operating costs came down because you did some process and the equipment modifications. Here you see that your capital cost was 41%, but after you added the heat pump section, it became 30%. So when you go into design business or the business of process design, you are going to see some of these already implemented in your by your company, let's say. But this is a systematic way of learning how to design, because before we learn how to use these, you may be told by your boss that go and use a heat pump. But why do we use a heat pump? What is the necessity for using the heat pump? If you do design in this very methodological way, you'll learn why you are doing things rather than just doing it. So, and then you can also come up with different ideas, and it will generate your ideas on where you can implement these design and why you need to do those things. So basically these are then just numbers, but this is the revised composite curve of the third case, integrated and intensified case. And you see that the two major overlaps of energy has been reduced. We have only a little bit of heat energy that is being used in this process. And you have solved or analyzed your entire process. But have you really solved or analyzed it to the extent that's required? And here comes in a lot of sustainability metrics that you can further calculate. So here you see that you have those flow rates. We looked at this design. We have these input flow rate, you have the output flow rates, you have all of these things that are going inside. But then you can do a calculation of the pollutants from your system. You have carbon dioxide, N2O, SOx, TOC, methane, and VOC. That can be potential pollutants from your system. And you use your emission factors to get to your final output. So you look at these pollutants, you do a tons per year analysis in the base case, integrated and intensified cases. And you have a base case with just waste heat recovery and waste heat recovery and off gas recovery. And you have calculated the numbers. So if you look at carbon dioxide, if you had a base case where you had a $25, if you put $25 per ton, this is hypothetical numbers, but if you look at $25 per ton of carbon dioxide, you're looking at somewhere around $25 million that you would be spending if there were carbon dioxide regulations. However, if you have done these base case, integrated case, intensified case, recoveries, and everything, you have actually reduced your carbon dioxide equivalent emissions to $7.93 million. And it's always good to have a dollar value associated with it, because then you can kind of like predict how much amount you are saving in this process. So 25 to 7, it's about $18 million in savings that you're bringing to your company. And you are doing a great design itself. Now, the cost-wise also, you see that the base case, integrated and intensified case, you have an internal return value of increase from 14 to 22%. And this is a special case where this increased. It might decrease because integrated and intensified cases especially need introduction of new equipment. But in this case, our propane-propylene splitter size went down drastically from our base case, which has caused the return value to go up higher. So these are some of the detailed calculations that you can do from this sort of design methods. Further down the line, what we can do is we have introduced a sustainability weighted return on investment metric, which is an extension of the return on investment concept with augmented sustainability metrics. I will not go into the details of this, but just to let you know that SWROI is a better improved method of doing your ROI calculations based on informed judgments, and these can be used for making decisions for different processes. Here is a list of SWROI metrics for the different cases. And you can see that we started with a ROI of 10 years. The SWROI is 10.71% compared to 10.38% for the base case plus waste heat recovery. But when we go and look at the integrated and intensified case and the savings that we make towards sustainability, we are actually having a higher sustainability return on investment for this particular case. If your traditional SW ROI was 19%, your SW ROI would be 25%. Now, again, a word of caution, this is because we did some really good design improvements for the integrated and intensified case, which has positively impacted our SWROI, but that may not be the case. However, if you have a company who is trying to make a decision to make any sustainability investments, at the basic level like this, you can make a decision. Let's say we'll have an investment in sustainability if it gives us an ROI of greater than 15%, let's say, and your SWI turns up to be 18% as compared to 19.45%. Would you make the investment for sustainability improvements? Maybe yes. And these methods help you in doing those calculations for sustainability investments. So with that, I would like to stop and thank you very much for your responses. I am going to try to copy all of these responses and go over them. Do you have any questions? I think there should be a lot of questions, right? Swamiji, what do you think?
This is the difference between the Indian student and the
No, I want questions. I want to hear your perspectives. What did you think of the course? Because
no, you see, you have already introduced this flipped classroom methods. Actually, as per our National Board of Accreditation system of the universities, so we are bound to have certain educational technologies. So one is this flipped classroom method. So we naturally apply, we train some of the students. Of course, those students are not here in this group. Actually, heritage students are very few. But I am very happy that at least 2 students has given the feedback. That means has
no, a
given,
lot of them have actually. They have sent it to me privately. So.
Oh, a lot of how many?
I'm trying to analyze. At least 9 students have sent me the feedback. So, yeah. But I'm trying to see how I can download this thing or pop it out or something so that I can save. Let's see.
I mean, can you not? Can you not access to those things?
Yes, I'm just trying to save this because let's see. Yes, I've gotten all of them saved. So yeah.
Oh, then it's really good.
Yeah.
Out of 18 participants, that 15, 9 have already submitted to you, and 2 sent in the chat box. So of course, maybe these 2 are common. I mean, that also may be the case. However, that means more than 50% students responded you. So this is a great thing.
Yeah. But I like to talk and interact a lot with students, and that is my way of engagement. So anybody who has any questions or anything for follow up, please do let me know.
Himanshu, you are there? Himanshu? Hello, Himanshu.
Yes, sir.
Why are you not interacting? What training you have got from me? He is engaged on project work. He is a final year student of chemical engineering. So
no.
He has been engaged
it would have been better in person because I like in-person interactions a lot. And
yes,
maybe next time when I'm in India, I will be there in the university and everything.
Oh, surely.
But Yeah, I mean, I always like to interact with people, and I like the questions that come, because if you do not ask questions, it is always like it's always rewarding to try to answer questions and ask questions, and so the interactions are very much important for anything that you do in the future. So
Sure.
don't feel shy to ask any questions.
Surely.
So,
Actually, today I was just talking with Provice Chancellor, Professor Chiranjeev Bhattacharya. I told that your student is very much enthusiastic. I told about you. He said, yes, he is always like this. So he was very happy to get the feedback from me.
yeah. All right, sir, I need
Okay,
to
okay,
jump
okay.
off. I have another meeting that I need to
Yes,
be in.
yes, surely.
So
Yes.
I'll definitely, if you have any more questions, please feel free to share my email with the students, and I'll be happy to
Oh,
answer.
surely.
Okay,
Okay.
thank
Okay.
you.
Thank you very much. Thank you, participants. So let us end the meeting. You can post afterwards also. I hope you have got the information regarding Swami Vivekananda's birthday on 12th. So naturally, if you are in Kolkata, you can try to this. ZCC is just beside the Big Bazar Saltec, that is the central government complex. So there we will have the function, and there if you can come personally, then you will get the hard copy of the certificates. Otherwise, I will mail you the certificates, and also you are invited to take the prasad, that means the noon food there. So I will from today onwards, every day I will announce this to check up with our resource persons, so that if they can come, we can also felicitate them. That is the idea. So with this few words, let me end the meeting. Thank you very much. Good night.